Dear audience, welcome to a Jubilee seminar in honor of Professor Yrjö Neuvo. The title for this afternoon is Education, Research and Innovations, Predicting the Unpredictable. My name is Ella Bingham and I will be your host today. We will start with an opening address by Ilkka Niemelä, President of Aalto University. Ilkka, please, the floor is yours.
Thank you, Ella. Dear audience, colleagues and friends, you are warmly welcome to attend this special occasion, Yrjö Neuvo Jubilee Seminar. A special occasion in honor of a very special person, Professor Yrjö Neuvo. A person who is very difficult to characterize by definitions, delimitations or generalization. A person known for breaking boundaries, overcoming obstacles and inspiring towards the new and unknown. Predicting the unpredictable in education, research and innovation. A real game changer. With this event, we want to show our appreciation and gratitude towards Yrjö. Yrjö has had an extraordinary, many-sided, exciting and successful career, as will become evident through the various talks given in this event. However, also for Aalto University, Yrjö is a very special person, to whom we are so grateful for his significant contributions. Yrjö's role was pivotal already in the formation of Aalto University as a member of the National Preparation Committee chaired by Raimo Sailas. The committee was set up to build a new kind of a university focusing on innovation and excellence. And many of the guidelines and recommendations of the committee are now part of Aalto University's way of working. From the very beginning, Aalto has been home to multidisciplinary collaboration. Yrjö helped to create Aalto's multidisciplinary platforms as an instrument of cross-school and cross-disciplinary collaboration. And, as well known, Yrjö's strong contribution at Aalto University has continued in various forms and roles during the Aalto University's first decade. As professor and research director, he has led Aalto-wide major research programs. For example, Yrjö has been the director of Aalto's MIDE program, Multidisciplinary Institute of Digitalization and Energy. The research program focused on long-term basic research in the fields of digitalization and energy technology, and created top-level expertise, strengthened education, and increased the competitiveness of Finnish trade and industry. The MIDE program, which ran from 2008 to 2013, gave a kickstart for the Aalto 1 satellite, which has then led to a booming space industry in Finland. The MIDE program supported also research in biofuel cell systems for portable electronics, energy efficient wood processing and many more. One of the talks today sheds light on how MIDE supported carbon nanotubes research. In addition to research projects, the MIDE program also included a postgraduate course called BitBang, promoting a wide understanding of digitalization of the future. BitBang was based on Yrjö's own experience working both in industry and academia, which triggered his interest to finding ways to increase employment of doctors in industry. One of BitBang course alumni will today share his memories on the course. And the journey continues. Yrjö is still active supporting and helping Aalto, for example, in fundraising. Dear friends, during these years, Yrjö has left an unforgettable mark, not only on the whole world, technology, business and Aalto University, but also on the numerous colleagues and students he has met here. In this context, I would like to share a few of these memories, as they are a good illustration of Yrjö's incredible diversity and his richness of ideas. Yrjö, congratulations for your amazing career. You have been a mentor, advisor and a role model to a whole generation of Finnish signal processing researchers and professionals, as well as played an important role in the success story of Finnish wireless industry. Best of luck with your ongoing and future endeavors in technology, science and science policy. Yrjö has an exceptional ability to inspire people's curiosity and keep discussions open for new ideas. He never insists and never gives up. That's a rare combination. Since the Big Bang course, I have always been pushing the boundaries of my knowledge outside my expertise. This is one of my biggest learnings from Yrjö during my PhD studies. I feel truly privileged that I was able to be one of Yrjö's students. All the best and warm wishes. Yrjö, I always remember you as a very warm person. You have faced younger people with the same dignity as more experienced scientists. It was always been a pleasure to listen to your thoughts and presentations and to learn. Thank you for these experiences. For my part, I would like to add a memory of Yrjö. I was serving as the Vice President for Research when we were developing ideas how to boost multidisciplinary collaboration in the new Aalto University. It was actually Yrjö who patiently and convincingly explained the importance of getting people together and inspiring experts from different disciplines to start working together on concrete challenges and research questions. So we can thank Yrjö for the foundational ideas of Aalto's multidisciplinary platforms. But I wonder, where is Yrjö at the moment? Could I reach him?
Hei Ilkka.
Hi.
Joo, tulossa ollaan.
That's nice. See you here.
Here I am.
Good to see you.
Good to see you.
Welcome Yrjö, great to see you here. Mikko Kosonen, the chairman of Aalto University Foundation Board, will now continue.
Dear colleagues and friends, Yrjö, how can we celebrate the illustrious career of a remarkable individual whose contribution to so many fields is beyond what one can say in a few words? Someone who, after a professional journey of more than 50 years, retains boundless enthusiasm. Let me begin with a few personal notes. I've known Yrjö across 3 spheres: as an executive in Nokia, as an academic at Aalto, and of course also as a friend, a personal friend. Across all these spheres, Yrjö's infectious enthusiasm, wonder of new technologies, and future orientation have been apparent. Yrjö is to me a role model of continuous renewal capacity, always learning, always interested in new things, and always imparting that orientation to all the people around him. A person who has realized great things himself, but also inspired countless others. If there is a Moore's law, there must definitely be also an Yrjö's law. Those gaining his contagious enthusiasm have gone on to impart that to many others, and so on and so on. One just wonders how many people have been touched by Yrjö in this way. The branches of this tree of inspiration must be doubling at least every 2 years. Dear friends, our title for today is Predicting the Unpredictable, which certainly has a strong link to Aalto University and Yrjö. In fact, many aspects of Aalto's strategy appear to parallel Yrjö's character. Our previous strategy until this year in Aalto was labeled Shaping the Future, and this is, if anything, Yrjö, predicting what comes next. Another quality of Aalto from the beginning has been, as Ilkka emphasized, multidisciplinarity. Who knows exactly how many disciplines Yrjö has been involved in, and how many bridges he has built between those. We also highlight innovation, and again, Yrjö has carried forward innumerable innovations, taking theory into practice, crossing between academia and industry. And now, in our fresh new strategy for 2021 to 2024, we highlight 3 new qualities. First, sustainability. That Yrjö certainly is a pioneer, connecting digitalization and energy, and an evangelist for electromobility. Second, radical creativity. Yrjö has continually brought forward new ideas, many of which we take for granted today. An anecdote from our audience guest for today, when at Nokia, Yrjö radically proposed color screens for phones. Others wondered why would those be needed for a device that we use only for phone calls. And last but not least, the third theme of our strategy, entrepreneurship. Not only has Yrjö directly commercialized many technologies in his own career, but he has also acted as a mentor to countless others, giving them the education, inspiration, and confidence to go forward. So how is it to embody all these elements of Aalto strategy? Is this a coincidence? Clearly not. These elements of Aalto strategy exist significantly because of Yrjö. His role in the foundation of this institution, his continuous contribution through the means mentioned by Ilkka and others. Yrjö is fundamental to what surrounds us at Aalto today. In fact, the characteristics of Yrjö predicted this outcome. So, dear friends, how do we predict the unpredictable? How do we understand what to build for the future of the society? I think it is obvious. Look at Yrjö's character and orientation, his wizardry of new technologies, and his approach to continuous learning. Take forward Yrjö's spirit that has brought us all here today, enthusiasm, wisdom, and not to forget, a great sense of humor. Let us keep these important qualities in mind throughout the day and celebrate Yrjö together by looking to the future. And knowing Yrjö Neuvo, he just might have some new advice. Thank you.
Thank you, Mikko. Our next speaker is Jorma Ollila, who was Chief Executive Officer of Nokia from 1992 to 2006, and Chair of Royal Dutch Shell from 2006 to 2015. Jorma will share with us some reflections of Nokia development and Yrjö's role there.
Thank you, Ella. Dear Yrjö, ladies and gentlemen, in autumn of 1993, I made a phone call to Yrjö Neuvo and asked him to come and see me as soon as possible. And he certainly did come over to my office. I had been Nokia CEO for 18 months, and I had a feeling that we needed some strengthening in the core management team. We had a discussion with Yrjö, which was very much the first time I had this opportunity, because even if Finland is a small country, and Yrjö and myself, we are both alumni of what now is Aalto University, as well as a particular high school in Vaasa, in western part of Finland. But we only had met each other in passing, and without too much hesitation, I was in a position to invite him to join Nokia team, the executive team, as the Chief Technology Officer, CTO, and member of the executive board. We had a feeling in the Nokia top team at that time that if we do certain things right, the company is on a road to becoming a real world power, a world leader in mobile telecom. But we felt that there were some areas where we really need some top world-class leaders to complement the know-how that the young management team was able to demonstrate. The technology area and a position of CTO was one of those positions, and particularly when GSM was in its first years of development, the standard had been specified, but nobody really knew how it would be made into workable working products in either networks or in the phones. Yrjö played a key role in Nokia's mobile success, in Nokia becoming the number one in mobile phones and a leader in network equipment. And Yrjö's contribution came from number of the abilities that he could bring into the team. First of all, he had this world-leading know-how in digital signal processing. My research sources told me that he was one of the top 3 people in the world understanding digital signal processing, having published academic papers on it, and having a broad understanding of what it was all about. So this was obviously a key reason. But Yrjö's contribution to Nokia was particularly strong for 2 other reasons. First of all, Yrjö's approach has always been multidisciplinary. So he always had the ability to see other technologies and how they affected the issue in hand, and had a very deep and broad, at the same time, knowledge of those technologies which could be employed to solve a problem or which affected the issue in hand. And equally importantly, what was important was that Yrjö was a researcher of basic research in his well-known discipline, but he also knew the applied research, and he had an understanding how all of that could be made into products. And this was really eye-opening, because I had always seen, to me anyway, because I had come to get used to that you have you often have three different people which you need. You need some fundamental basic research know-how, you also need applied research, and that might be a different person, and then you need to have a product guy, so to speak, to understand how do you bring all that to products. So it is not common in top companies to have these three abilities in one person. And Yrjö's contribution in Nokia very much emanates from the fact that he had this exceptional grasp. At the same time, obviously, as already mentioned by my colleagues here, the wonderful personality that Yrjö could bring into the team. His humble working style, listening to different viewpoints, being a team player, so that he inspires people to get the things done with his friendly approach is something unique. I think the way in which Yrjö was one of the key outside people that we could bring into Nokia in the 1990s to complement the internal know-how and the young entrepreneurial thrust which the early 90s team that I started with, we could then complement with a number of other similar players from outside. Juhani Kuusi came about 18 months after Yrjö to run the research center, and the partnership the two of you played was instrumental in Nokia having today the patent portfolio and the understanding of the role of research in technology companies. We also had Frank McGavin to join in to run the manufacturing and to creating a culture which was world class, and Frank Nuovo coming in to run the design on the phone side. So there was Yrjö really being an example also to many of those complementary additions that we brought into the team and in the top level. So there's a bit of a management lesson that you have to be able to combine both the newcomers, pick the new ones, and then combine that with a team which has been in the company for a little bit longer. Yrjö, your contribution to Nokia was exceptional. We all feel a lot of gratitude today from what we learned from you, what we learned together, and what we were able to bring as an example to many of our colleagues in different parts of the organization. So many thanks, Yrjö, for all the years, 12 years you spent with Nokia. Unforgettable years. Thank you very much.
Thank you, Jorma. Our next speaker is Matti Alahuhta, who was the first chairman of the Aalto University Foundation Board. Matti held several executive management positions at Nokia during Yrjö's time there, and Matti was Chief Executive Officer of Kone Corporation from 2005 to 2014. In the following video, Matti will share with us his thoughts on Yrjö's role at Nokia in the spirit of predicting the unpredictable.
Dear Yrjö, ladies and gentlemen, I first met Yrjö in 1976. Significant progress in digital signal processing had just started. I was doing my Master of Science thesis in this area on the topic of using delta modulation in PCM coding. I was happy to get guidance in my study from Yrjö, who was one of the leading researchers in digital signal processing and who had just returned from the US. Yrjö made a strong impression as a person who is always curious to learn new things and help others. Yrjö started at Nokia in 1993. I will now tell about a couple of our shared experiences during our time at Nokia Mobile Phones. The first one is the way how we successfully dealt with the collapse of the mobile phone market in 2001. This market had experienced exceptional growth rates, close to 70% both in 1998 and 99, and about 45 still in year 2000. Then growth suddenly dropped below zero. Due to our strong market position and our extensive distribution network, we had been able to predict this happening. By rapid actions, such as focusing our R&D activities with Yrjö's leadership to the completion of the most attractive new products which had faster data speed. This is the way we succeeded in further strengthening our leadership in this demanding situation. The next question was, how would the market develop from now onwards? We tried to predict this unpredictable question in various ways. Yrjö did again a great job by making forecasts based on Moore's law and the assumptions of the speed of expansion of new features and technologies in mobile phones. In comparison, he also used historical watch market data. Market growth returned to positive already in 2002 and grew by about 15% in 2003, followed by faster growth. But mobile communication is more than handsets. One of the key areas are international standards. The turn of the century was very active time in new technologies. When 3G standardization was completed, Nokia brought its first 3G phone, Nokia 6650, to the market in 2002. 3G standardization was an intensive competition between two alternatives. With Yrjö's leadership, wideband CDMA, which was supported by Nokia and Ericsson, won this very important battle. The beginning of the era of smartphones was symbolized by Nokia 7650 featuring in the front page of The Economist in November 2002. Nokia continued to actively develop both Symbian and Linux-based smartphone platforms, bring new technologies and products to the market, and strengthen its IPR portfolio. Yrjö's contribution at Nokia was significant. Yrjö and I became good friends during our Nokia years. After that, we became family friends. Our summer places are close to each other in Raasepori. Our hobby is boating, which we have enjoyed with various success. Yrjö and Tuula have been very helpful to Leena and me by bringing firewood for our sauna and fireplace. Yrjö driving his Avant first, followed by Tuula with her own Avant. And whatever technology problems we have had, Yrjö has always been ready to help. All in all, Yrjö has exceptional visions of innovations and trends in telecom technologies, from basic science to consumer products. Yrjö, it has been great to work with you.
Our next speaker is Professor Matti Pursula, who was the rector of Helsinki University of Technology, one of the predecessors of Aalto University. Matti will shed light on the period starting from 2005, when discussions of a new university were initiated. Matti and Yrjö were both members of the preparation committee established by the Ministry of Education. As Matti will tell us in the video, during the process people became convinced that the idea is great, as the understanding of the advantages became apparent. And here we are. Aalto became reality in 2010.
Good afternoon, Yrjö, and all Yrjö's friends and colleagues. It's a pleasure to be part of this jubilee seminar. The subject given to me is to discuss how Aalto was born, especially the work of the preparation committee known as the Sailas Working Group. I start with some background information. Rector Yrjö Sotamaa, TAIC, University of Art and Design Helsinki, proposed in his opening speech of the academic year 2005 a merger between Helsinki University of Technology, TKK, Helsinki School of Economics, HSE, and TAIC. According to Sotamaa, this kind of a merger, creating a new kind of university, an innovation university, would be much more beneficial to Finland than the 10 timely proposal about a merger between the Helsinki region art universities, including TAIC. The Innovation University proposal aroused much attention, and the rectors of the other two universities kept it worth further discussion. During the fall semester 2005, the rectors created a very short preliminary draft about the basic ideas of the possible new university. We, the rectors, even made a short trip to USA to get to know Harvard and MIT as examples of top universities. We discussed, among others, with Professor Bengt Holmström at MIT. At TKK, the university board discussed the proposal on the 12th of December 2005. The board was very critical, and the discussion resulted to a conclusion that this is not the way TKK should go. The only ones for the proposal, as far as I can remember, were the student union representatives. The industry members of the board, Timo Poranen and Yrjö Neuvo, shared the board's negative feeling about the possible merger. It is, however, important to note that the Innovation University was only a discussion point in the agenda of TKK board. So no official decision to reject the merger was never made. Because of the TKK board opinion, the rectors of the three universities in early 2006 created a proposal for a common innovation institute instead. The proposal did not satisfy the Ministry of Education, which at that time strongly pushed the universities of Finland to renewal and cooperation. The ministry, at the end of October 2006, founded 3 separate working groups to promote university cooperation. One of the groups had to make a proposal for as deep a cooperation as possible between HSE, TAIC, and TKK. The Minister of Education nominated the Secretary of State, Raimo Sailas, from the Ministry of Treasure to chair the working group. The other members of the group were the rectors Eero Kasanen, Yrjö Sotamaa, and Matti Pursula. plus the industry representatives Yrjö Neuvo and Matti Lehti. The Secretary General of the group was Professor Turo Virtanen from University of Helsinki. In addition to that, the three universities gave secretarial help to the group. Yrjö Neuvo had experience as a professor and as industry leader and had chaired the Ministry of Education working group on the development of the engineering education in Finland. Dr. Matti Lehti was at that time the Chancellor of HSE. So both industry representatives had knowledge and inside experience of university administration and culture in general, which was very important to the success of the working group. In the first meeting of the working group, I stated the points which, in my opinion, were the boundary conditions of TKK for a possible merger. In a nutshell, TKK is and will be a strong research university. Therefore, we should not aim for and discuss about something called the Innovation University. So the group in its work used the term top university. Yrjö Neuvo very much supported my views. The basic discussions in the working group were in general positive. All the members tried to find solutions in the critical questions of the idea and principles of the possible new university. In my opinion, one very important additional point was the statement that the new university is a national project which benefits the Finnish society as a whole. Of course, some disagreements and delicate points existed, but they could be solved, like, for example, the question of the future campus structure, which was stated in a tentative form. The possibilities of Otaniemi campus should be investigated. Raimo Sailas chaired the working group with a neutral position and supported the goals of the merger. He took a positive view to the idea of foundation-based university, to the state share of the endowment capital, and to the doubling of the yearly financing. He also understood the importance of the transfer of the facilities to the new university. I remember him stating that he supports all these proposals, even though he knows that his colleagues in the Ministry of Treasure will oppose them. Yrjö Neuvo and Matti Lehti were active and constructive members of the working group. One important part of their work was to cooperate with the background group from the industry and to promote the idea of the industry share of the university capital and to estimate the possible amount of the industry donation. The work was successful, as we know. When the merger proposal in details was known, the boards of all the three universities supported it unanimously at TKK on the 12th of March 2007. From the above mentioned, we can see that Yrjö was both active and important member of the Sailas group. From TKK point of view, he was a strong supporter for the most important goals of TKK and Aalto, the creation of a strong research university with new kind of teaching and learning culture with students in the center. And his work in the background discussions with industry and later on with TKK professors have certainly been important in the process of the creation of the new university. The Sailas work group did, from the point of view of TKK and Aalto, result to another important action too. Yrjö lived at that time in Tapiola, and very often we did travel to and from Sailas group meetings in a TKK car. So we could, among other things, discuss the meeting agenda in advance and afterwards. At that time, Yrjö was retiring from Nokia. Therefore, in one of those common trips from the meeting, I made Yrjö a proposal to join the TKK staff as a research director with special tasks to be defined later. This way, Yrjö became again a member of the TKK staff and, among other things, the director of MIDE research program. In MIDE, he again demonstrated his ability to create something new, like the successful Big Bang doctoral course and a flexible research program with minimum bureaucracy. To end up, as I stated, Yrjö's immediate reaction to the Innovation University proposal as a TKK board member was negative, but changed later when the goals and boundaries of the top university project with his cooperation were properly defined. Well, Yrjö was not the only one to hesitate. To your comfort, Yrjö, I can state that among others, Professor Bengt Holmström at MIT did not see any real benefits in the proposal when the rectors discussed with him in December 2005. And after all, he became a member of the first board of the Aalto University Foundation. So Yrjö, you were in good company. As a closing remark, the heading of this seminar is Predicting the Unpredictable. The result of the Innovation University proposal was clearly unpredictable in fall 2005. But the Silas Group was able to formulate the case and to set the goal for a world-class university in 10 years. Today we can see that it has been achieved thanks to the real commitment and hard work of the Aalto community. This way the unpredictable has become possible. Ladies and gentlemen, thank you for your attention, and thank you, Yrjö, and all the best for the future.
And now it is time to give the floor to Yrjö himself. Yrjö's Jubilee lecture is titled Education, Research and Innovations, Predicting the Unpredictable. We will start with a brief video.
This is the world's first GSM hand portable phone. The earlier ones were kind of shoebox size, and it was really remarkable achievement to integrate this. This happened roughly at the time when I came to Nokia. During the GSM standard development, we had rather big contracts with Nokia at Tampere University of Technology, so this was kind of a highlight of that development also. Okay, this was only speech, and if compared to current phones, the speech quality was not that good, not that good at all. It had a text messaging possibility, but no internet connection naturally. If you compare that to today's phones, the difference is enormous. This is just unbelievable development that we have had, and it's not only Moore's law, it's many other technology developments that have taken place and have enabled this kind of a development. It's just amazing. Ladies and gentlemen, the title of today's seminar, as we have heard a number of times, is Education, Research and Innovations, Predicting the Unpredictable. To me, the title reflects the speed of technology development that we are currently experiencing. In technology development, 10 years is a very long time. How can we prepare for this? Harry Potter had it easy. At the Hogwarts School of Witchcraft and Wizardry, he had two extremely valuable textbooks. One was Predicting the Unpredictable, and the other one was Unfogging the Future. I've read all the Harry Potter textbooks in English and really enjoyed the imagination that the author had when she created this artificial world. We, the ordinary people, don't have these magic textbooks available. However, we can compensate this by having a positive attitude towards new developments. For instance, curiosity and continuous learning are tools that we can use to compensate for this handicap we have. I will elaborate this human side after first looking a bit at the speed of technology development that we are currently experiencing. The famous Moore's law tells us that every 20 years we get the performance of integrated circuits grows by a factor of 1,000. In 40 years that means 1 million factor of improvement. And we get the additional bonus. The size of microelectronics components shrink dramatically. Amazing examples of this development are these Finnish wearable products. Both have a small computer inside, sensors, battery, display, and in a very small volume. Thank you. The end of this exponential technology development has been predicted year and year after year. However, the strong market pull combined with advances in basic research and breakthroughs in technology development have been able to increase the lifetime of Moore's law over and over again. But it is not only microelectronics that improve exponentially over time. Radio spectrum is a finite natural resource. However, and despite the opinions of experts, we have not yet this limit. Your mobile phones here in this picture we have mobile phone base stations, this kind of tower, and then with the area the mobile phone base station covers. And what has happened over time is that the area that the one base station covers is shrinking, and when it shrinks, you get all the spectrum reused in a number of neighboring places. So you get a lot of more capacity from that. And when we go to smaller base station sizes, we also can use higher frequencies, which again increases the speed of communication. And what has happened here, I have a title, Mobile Networks Moore's Law. What has really happened in practice is that mobile data speed have doubled every 19 months over the lifetime of cellular phones. So this is a bit faster than the Moore's Law itself. It was 2 years, 24 months. And how it happens? In 1980 we had the first generation. In 1990 was 2G, GSM. 2000 it was 3G, 2000 and so on. And now we are in 2020. This is the time for 5G. And after 10 years we have 6G. Sounds very simple. However, to make this progress will require quite a lot of research, innovation, business model developments, etc. On this slide, you have kilobits per second, megabits per second, and gigabits per second. When we go from kilobits per second, where we started, go to gigabits per second, the improvement in data speed is a factor of 1 million. Quite significant, amazing development that we have experienced over these years. You may ask why it goes like a clockwork every 10 years, next generation. The fact behind that is that we need to have global standards to implement the network, so we have to prepare to the next phase so that the whole world will be able to use the technology. And it means agreements between different parts of the world to make it happen. But really, we are now entering the 5G phase, and now we have 6G on the drawing board already. And there's quite heated discussion what it really means, what kind of new services we can put there, and how can we go to, let's say, increase the data speed again with a similar manner. The fact is that will require again a lot of breakthroughs from basic research in many different domains, including, for instance, artificial intelligence, when the networks are getting even more and more complex, how to manage those. But work has started pretty well also here in Finland. I'm very pleased to have noticed that. Okay. There is one more exponential law that is related to mobile communication. It's called Metcalfe's law. It tells that the value of the network increases roughly as power of 2 of the nodes that are part of the network. If you have two points, there's only one connection, but if you have 5 points, 5 people connecting, there are already 10 connections, and then gradually it goes to the power of 2. This is a very powerful development. Once you are able to create one network with big enough nodes, it is very difficult for somebody else to enter the competition. This is an interesting book from 1896. A British lady, high society lady, visited Finland, and in her book she describes how Finland is really full of telephones. It was something new for her that telephones can be used at homes and so on. And on the chart below that we see countries that are most using mobile data services. Finland is number 1. This is from 2018. And then comes another country, then Latvia, Austria, Iceland, and South Korea down there. Why are we that good? Or is that good, but using anyhow? Most of the data is probably quite a lot with the strategy of the operators. Maybe we are a bit technology freaks also, a positive attitude to new developments like Ms. Alec Tweedy noticed already more than 100 years ago. Still related to this network effect, here are the most active social networks worldwide. Facebook has more than 2 billion followers, participants. YouTube comes next, and 2 billion. When you have reached this level, you are leader in a certain type of certain application. It's very difficult for somebody else to take that role. You rather have to create another network that starts to grow from a different perspective. But this is also a good example of Metcalfe's law. Here is a pretty wise statement. When wireless is perfectly applied, the whole world will be converted into a huge brain, all things being particles of a real and a rhythmic whole. Think about this. And who said that? It was Nikola Tesla, who lived from 1856 to 1933. And he was seriously working to create a worldwide wireless communication network. He understood the theory. He was more than 100 years too early, that's a fact. but he was really seriously pursuing it. Okay, he could not finish it. His project, he ran out of funding also, but excellent visionary thinking and very good understanding, especially understanding the time of electromagnetic fields and waves. The role of basic research. I have so far spoken about the exponential developments arising from microelectronics computing and wireless communications. The question that easily comes to one's mind is that are there new technologies that are in the future or can have in the future as important role as microelectronics and cell phones have today, and where they could possibly come from? Will there be another Moore's law? Nobody can predict, at least I cannot predict where this kind of development could come. But I will follow one path. What it will bring, I don't know, but it's just an example of the speed from research to industrial application, how it really happens. I got exposed to this thinking during the MIDE program. This was a 20 million euro Aalto University research program where, as has been mentioned, I participated. So I got the idea from that program. One of the projects at the MIDE program was carbon nanotube research. Professor Esko Kauppinen was the head of that project, and he told me that out of carbon nanotubes you can also make transistors. Carbon nanotube is a small tube, as you can see there, but the diameter is a couple of millions of millimeters. So extremely small nanoscale elements, and they can be metallic conductors, good conductors or semiconductors. Semiconductors are used to make transistors. So my own thinking was that okay, nanotubes are interesting. Can they create a new semiconductor industry? So I was kind of casually then following that development, and then this was about 2006 was an interesting article. First it tells worldwide economic activity associated with electronics. The semiconductor industry alone was 2015 billion dollars, but electronics is $1 trillion, so 5 times more. And then IT-enabled services, $5 trillion, much more. So it just shows how important this semiconductor industry is for the, let's say, world economy. So this happened, and there was in this article, the authors explained how they have been able to put nanotubes in a transistor structure, and actively tested it also. This is Japanese research. And the story goes on. 2011 came this article. First nanotube integrated circuit manufactured. And you can see it's transparent, it's bendable, so completely different type of electronics device that we have experienced so far. The current silicon is like stone, it breaks easily. So this came out in 2011. And then last year came the first nanotube processor. The MIT and Analog Devices had created it together. It has 15,000 transistors, There's a lot of materials science research, but the important point that I want to stress is that computer architecture was also an important contribution to this research. So materials and computer architecture researchers working together made it possible. The problem in this kind of development was that you can make good nanotube transistors, but every now and then there is a metallic nanotube in somewhere in the circuit, and the metallic nanotube can make a short circuit. So they had to design a computer structure that could tolerate a small number of metallic nanotubes among those semiconductor nanotubes, and there they needed the MIT help. So this may be one path to the future, that it is more and more cross-disciplinary research that one has to do to make breakthroughs. I don't know if this ever gets more than this, what we have here today. But the positive thing is that as a result of this Esko Kauppinen's project, we now have in Vantaa a very big nanotube factory working for completely different applications, self-driving car applications and many other things. I'm sure Esko Kauppinen will tell what is there happening today. But this was just one example of the speed from basic research to some prototype, and also the importance of cross-disciplinary collaboration. Now I move to the second part of my talk, which is doctor's career paths. I put the doctors in parentheses. The history behind this whole presentation is that I was invited to give a talk to Cambridge University doctoral students. It was supposed to happen last spring, and due to Corona, I could not go there. Then it was postponed to fall of this year. Okay, I could not go there, so I thought that I could use it here as a slightly modified version of that presentation. If you think about one's career, often the question is it theory or practice, or is it industry or academia? And with this slide, I want to emphasize that it is not either or. There should be both and component also. These circles, this is a kind of a hill, two valleys, the valley of industry and valley of academia, and these balls are people. If they are balls, they should have, the idea is that you should have enough kinetic energy to be able to visit the other valley, not to stay in one valley only and oscillate there, but have enough energy to do that. And for universities and research organizations, it's important to try to lower the hill in between those two areas. So get it down, and for persons to have enough curiosity, enough energy, desire to learn, to visit the other side. Also, and if you can do the visits, you also learn, and you get you get new ideas, new innovations. The advantages are obvious. So this is my kind of visual view of the multidisciplinarity and curiosity. When we had at Aalto the energy efficiency program, this is the slide that we showed to the people who prepared projects to this program. Think broadly. And upper left corner, improving the efficiency of a present technology. That is kind of an obvious thing to do, to make, for instance, a more efficient engine to a car, less pollution, etc. Then the second corner, right-hand corner, switching technology to perform the same task, so going to electric car instead of combustion engine. That is obviously more environmentally friendly, and definitely increases the energy efficiency of the car. Then the yellow box, that's okay. Rather than developing cars, we should personal cars. We should have invest in more modern public transportation. That's an alternative also. And the last option there is that making wide-reaching changes to what is done. Removing the need to move. Use wireless communication, internet, and other means to do the collaboration. This was kind of a metaphor for when we were setting this program. Think broadly, and we got pretty good proposals. And also good results out of that program. My view on the research or research collaboration is like bartering, vaihtokauppa. You have to give in order to get. Network with other researchers, discuss with other people, be curious, look around, visit the industry, academia. And then another point which is surprisingly important occasionally, follow strict academic ethics and principles. Be rather liberal in thinking whom to include in papers and publications. Rather more too liberal than too strict. So really take a liberal view who to include as authors and inventors. They are happy when your name is there, and they may pay it back one day. Then the competence or curiosity profile of a person. On the horizontal axis we have disciplines, and the vertical axis is the competence deepness. A person can have a very narrow specialty area, like the most right hand curve indicates, and very little interest or knowledge about further away from that top. And then two other alternatives. The point I want to make is that it is important to have a certain amount of breadth and width. Technologies come and go, research topics change. That requires an ability to move around. And then when we go to collaborative research, it's more and more you have to understand also what is happening in the neighboring areas. So I really, what is the right amount? These are, for each case, it's difficult to say. But I know professors who are world's best in a certain area that has been outdated like 20 years ago. They can still publish good papers in that topic because they can review each other's papers, but nobody else is interested about that. So this is the kind of a saddest case that can happen if you don't look around during your career. Okay, I thought that it's good to have a formula also, mathematical formula in my talk also, and the topic is grow your knowledge capital. And your knowledge capital comes from continuous learning. It's a bit like putting money in the bank. And when you put your money in the bank, there is a certain interest rate that you get. Here, letter R denotes that, and the capital grows exponentially over time with that certain interest rate. So R, e to the power R times t. And you can then estimate, you can calculate roughly what time it takes to double the capital. You take a serious expansion of the exponential power, and you can get the simplified version if the question is when is that capital doubled. And the result is that the time it takes in years, okay, in this case in years, to double the capital is 70 divided by the interest rate. So if the interest rate is 7, it takes 10 years to double your capital. If the interest rate is 5, it takes 14 years. This is a bit analogous to learning also. You have to learn, things get obsolete, new things are coming. You should be all the time curious what is happening in the future, and you should invest in your own human capital. And I think this is a pretty good formula that encourages you to do that. You may need that capital growth also because your job description is changing. Anyhow, something like investing about 5% per year to renewal is a pretty good rule of thumb, meaning there is 14 years of doubling. Career planning. At least this is what I have been thinking. Like what you do, career planning is less important. And then at young age, test your limits. Do radical things. It's much easier to do that when you are young than when you have lot of other commitments. And this, which I think is also important, and I think I'm sometimes a bit worried about this point. Sacrifice short-term economic benefits over continuous learning and growing your human capital. So don't look that much money. It's more than you really get. It's really valuable to do this. Look broadly and really think what is your capacity also in the future. And then go abroad. It's a pretty good, or get wide experience. It can be also industry academia, but do take this kind of moves, and all these are much easier when you are younger. Thank you.
Thank you, Yrjö. Before we start the break, we will have a small gift for you, and I will now hand over to my colleague, Sam Cross, Manager of Energy Platform.
Thank you, Ella. Dear friends and colleagues, how to find a gift for Yrjö that would give some reflection on his remarkable career and our affection for him. Something not too serious and something a little bit unique. Let me first tell a story. If I could have the slides, please. Thank you. Today's seminar title, Predicting the Unpredictable, is adapted from the Harry Potter books. And indeed, Yrjö and Harry Potter go back a long way. Here is a BBC article from 2003, when Yrjö was CTO of Nokia, admiring J.K. Rowling's ability to predict the future, and indeed ideas that were later incorporated into mobile phones. And then, in 2019, a reference in Technica ja Talos. But there's another question. Can we see a resemblance? And what about characteristics, intelligence, learning, wisdom, and humor? There is definitely a connection there. And so we decided to put Yrjö and some key career colleagues, Jorma, Ilkka, Matti, and Tuula, into the appropriate context in this artist's view, under the title of one of Yrjö's key contributions throughout his long career, Turning Theory into Practice. And with that, I would like to ask Yrjö to step up to the podium and ask Ilkka Niemelä to present the real article. Thank you.
So Yrjö, it's my great pleasure to present this small token of our gratitude and appreciation for all your contributions towards the Aalto University and Finnish society. Something that makes sure that Aalto stays with you.
Oh, this is unbelievable product. I cannot. Fantastic.
I hope that you enjoy that.
I really enjoy it. Who has made this?
Sam, we'll have the explanations in a moment, but
okay.
And then Mikko, please. The even more important thing.
Okay.
More important thing is there's always somebody that really gives the crucial support, and I think it's for you, Yrjö, it's Tuula.
Okay. This will find a very special place in my home. Thank you.
You're welcome. Yeah. Sam, could you explain the artist?
Yeah, absolutely. So the artist of this picture is a gentleman called Richard J.O. Pope, and you can indeed find a Facebook profile for him at the Cartoon Chap. Thank you.
Okay.
Thank you.
Very good. Thank you.
When I was doing my master's degree here, I kind of made an own ranking of professors in my mind. Who are the most interesting professors at the Department of Electrical Engineering? And all the three ones had been abroad, at least 1 year. One could approach them easily, ask questions as a student. They took their time to discuss with me, and they had some interesting research backgrounds also. There was Martti Tiuri, Seppo Halme, Veikko Porra. Had a slightly different tone in their activities. You cannot measure it exactly, but it was a feeling. Opportunities here were a bit limited. And in that area, which was signal processing, digital, there was very little activities in Finland. I felt let's try and got the Asla Fulbright scholarship to study in the US, and I had basically two universities to choose between, and Cornell had a very good doctorate record, production record, and was in a very nice location, small city, suitable for this type of young family, and well-known Ivy League university also, so one of the good ones. The thesis defense in the US is rather different than here in Finland, so it was a professor committee who decides if the thesis is accepted or not, and the day the examination was to happen, I was in my office at the Cornell University at the Electrical Engineering building, and there was shouting in the corridors that the professors were arguing. One of them said, "I will not come to this defense. He hasn't studied long enough here. No way. I will not enter the room at all." And they were shouting in the corridors, and that was kind of a good start for the thesis defense. After a while, the two other professors managed to calm him down, and then the examination started, and it was successful, but the starting was really bad. I was getting nervous. What is going to happen now? The title of my thesis is the Analysis and Digital Realization of a Pseudo-Random Gaussian and Impulsive Noise Source, 1974. It included, in addition to theoretical analysis, of the noise characteristics generated by the algorithms, but also implementation of the algorithms on a digital hardware, which is rather, I would say, unusual. Part of my work at Cornell was funded by US Air Force. At that time, computer resources were extremely scarce, and I got permission to use Air Force-based computers. I could go there by myself. I got through the gates. I got to the room where the computer was. I could use it there. If I wanted to go to restroom, I needed an escort. But for computer use, there was no limitation, and that was quite important for the computer simulations and analysis that I had to do for this work. If you take kind of honest picture on the evaluations, Nokia had done the best work, but it was impossible for the competition to admit it. Trying to ignore our work and kind of praise their own work, but there was no. It was kind of the facts were on our side, but it was just that we were kind of a new guy in the block. We were a newcomer in this business, in a way. Everybody was praising his company's own technology, and this continued, and there was now seemed to be no end. But eventually, IBM said that, "Hey guys, it looks like Nokia has done the best work and has the best coder. Why don't we accept that?" So IBM, that was a bit kind of neutral and was not biased in a way. So that solved it, and that was the first essential patent that Nokia obtained, and that was in the speech coding area, and has this kind of history behind it. It was a small team, but they really worked really hard, and after that, the rest is history.
Welcome back. The next speaker is Professor Esko Kauppinen. Esko's publication list is highly impressive, containing publications in science and nature nanotechnology. And he is the first Finnish recipient of the UNESCO Nanosciences Medal. Esko has also been active in the startup scene. He is the founder of companies Canatu, Metalcirc and Teikos Pharma. Esko was one of the research group leaders in the MIDE program chaired by Yrjö. Esko will join via Zoom.
Hello, I hope you can hear me. Is it okay? All right, so I use slides. This is kind of a bit of a scientific talk. Let me try to get it to the full screen. Okay. Just a minute, it's coming soon. Okay, all right, so now we are on the way. These are my slides, and then first, congratulations to Yrjö for the very long and interesting career in many fields in science, engineering, business, and also education, and starting our university. So I talk a bit about the nanotubes and the industrial application, also a bit about the media history and what I have done with Yrjö. Now, this is about the carbon nanomaterials I've been working a lot with. We have a diamond, we have a pencil, and this is then the graphite. And if you take one atomic layer, this is graphene. And if you can see me, I have now this tubular structure in my hand. Also, we have this is the nanotube, about 1 millionth of the diameter, 1 millionth of millimeter. We have also spherical, the ball, like Adidas ball foolery. And then what we invented in Finland, in my group, was how we can merge these two. And that's now called carbon nanobud. And I have some figures, and I will discuss a bit about these too, because somehow scientific community want to compete. Some people like nanotubes, some people like the graphene, but I think they are very similar. So the media program that was discussed, I had a project called Carbon Nanobud-based energy system for mobile devices.
Esko, excuse me, can you switch to full screen mode?
Okay, so then this was the project Yrjö mentioned about the media, and then we worked on that. And there were several highlights. This is historical. This was the first time the nanotube transparent film was reasonably conductive, almost as good as the existing metal oxide, and that we published. And this hidden media project was also very important in the way that during that we started very important Japan-Finland collaboration. And later there were European-Japan collaborations in that respect. That was important. And I learned also that Yrjö had a lot of Japan collaboration in his historical time earlier. But then what actually was the invention we were working, that was really my invention, was to make the carbon nanotubes in the gas phase and then decorate with fullerenes and make also thin film. And this thin film then turned to be the one that we can really make application. We started also a company that was mentioned earlier, the Canatu company that started making the reactors, making the film and looking for the real application. And then I met Yrjö and we had a good discussion about this during the media project. And then I invited Yrjö to join our team as the board member. And Yrjö was really important in many ways. He had experience and he know how long it takes. And we all were pretty much too busy. So this was the Canatu team 2009. And now, of course, the team is much bigger. And then Yrjö helped us a lot and we had good discussion. I will show some later. This is now then how the nanotube really looks. It's like the spaghetti, and interestingly, it can be conductor or semiconductor. We can make transistors, many touch sensors. And then that's what we started to manufacture. And then in the time of this media program, we made many demos. Yrjö said that we need to first demonstrate. And of course, that was a very good idea. And then we demonstrated OLED, solar cell, and also we put nanotubes on the metal. And interestingly, we made the first touch sensor. And actually, this was the thing that Yrjö's big finger broke, maybe at least once. But we could demonstrate that we can replace the metal oxide with the nanotube. And of course, nanotube is then interesting that it can be made flexible. We then, in the company, Canatu guys made this kind of touch sensors, which is exactly similar as used in the normal phones. And that worked similarly. Actually, optically, it's nicer. And then also, this shows that the nanotube electrodes can be transparent electrodes. Touch sensors can be made large. This was A4 size for that. That was worked with the many companies, Intel, Atmel, to demonstrate it. You can use it in the big in the laptop. So actually, at that time, even now, the displays aren't really bendable. Our touch sensor is, but displays are not. But now they're coming. And then interesting thing that recent innovation important is to use flexibility, is to use make 3D touch device where you have really features. And that is emerging to be used in the future in the cars as the center information display. And this picture shows why it's very useful, because we can put roughness on the surface and still it works electrically. And you can feel where you are. You don't need to see. And in the driving, for example, it's useful. And then recently, what Canatu is really developing is to make touch devices in menus, things, and also heaters. And that is now interesting emerging area in this field. So, and this is the factory then Yrjö discussed, where mainly nanotube thin films are made for mainly sensor and also some imaging energy electronics application. Transistors are really still tough, but maybe someday we can make very small, fast transistors. Okay, so I just share something about the interesting future research ideas. Normally we think carbon is black. But we just recently, this was published a couple of years ago in the JACS, in the nice high-level journal in USA. We showed that we really can make very beautiful colored carbon material. And this is innovation. When we learned this by tuning the the atomic structure of the nanotubes very detailed. And this was an interesting innovation. Maybe we find good application with that. Then the other thing I showed in the beginning that we have this Superman and Batman strong guys, and then normally people want to like compete. Europe is putting a lot of money to graphene flagship, and Asian countries maybe more to nanotube. And my question is, do they compete or can they collaborate? My thinking is research collaboration is very important. And actually we combine these two nanomaterials, this 1 nanometer tube and even thinner 1 atomic layer thick carbon, and we figured a way how we can really put them together to make this transparent film. And then actually it turned out very interestingly that if we put them to collaborate, we could get this number. This is just a number that is the seed resistance or about the conductivity. We can get much better than they are alone. And this is important. Also in the research, one need to collaborate. And in the materials, we need to work together with materials, not to put materials fight between each other, because the challenge is to really find any reasonably good application for new materials. There are so many new materials. So I think I would like to still once more thank Yrjö for many years to come, and hopefully we can discuss in the future. We have had good afternoon discussions many times, or lunch discussion, and I really enjoyed and happy to join to give this short presentation.
Apologies for the technical problems. The next speaker is Professor Moncef Gabouge. He is Professor of Signal Processing at Tampere University, and he is also IEEE Fellow. Professor Gabouge was Yrjö's colleague in the 1990s, and they have written highly cited papers together on median filters and other topics relevant for mobile signal processing. And Moncef is also joining via Zoom.
Can you hear me now?
Yes, please.
Great. Hello, Yrjö. Hello, everybody, and happy to be here. I'm so proud and honored to be here with you today, remotely, but still there. In the next 10 minutes or so, I'm going to tell you a little bit about our 30 years of signal processing, the long journey with Yrjö along this path. So the first place I'm going to start with is where we are at the moment. At the moment, we're looking at different layers of analysis, starting from the bottom layer, which is our signal acquisition and images and videos, and going all the way to a specific application on top. But before we get to any great application on the top, we have to pass by a number of layers. And the main layer that we have done a lot of work with Yrjö was the base layer. This is the founding pillar of everything that we have been doing in the past 20 or 30 years. So signal processing, signal representation, sampling, denoising, encoding, feature extraction. This is extremely important. We have been fighting a lot of fronts and coming up with great ideas. Before I joined Tampere, before I came to Finland, when I was at Purdue University, I started that and continued the path along the way. The next layer is an analysis layer, so deeper analysis layer with a modern deep learning, with a modern optimization and representation. And then the final layer is the application layer. This is where we interface with the different applications and different companies. So the first part of the work, the basis, the pillar, came out to be a great area of research. It led to many breakthroughs in nonlinear filtering. So Yrjö probably recognized the area very well on the left. That led us to continue the work into mathematical optimizations, machine learning, and pattern recognition. And the book was also translated to Chinese. So Yrjö probably remembers that back in the old days, we tried ECG analysis. We, in fact, at that time, if I recall correctly, we had ECG signal representation with splines, with Marta Kartsevich, one of my students earlier, who is now vice president of Qualcomm. But now we're looking still at that problem, but in a bit different view. We're looking at real time. We're looking at patient-specific, that is person-specific ECG type classification. We are combining signal processing and also machine learning. This case is one-dimensional convolutional neural network. And we're making that algorithm so efficient that it can work on a mobile or a portable device. We also looked at many other applications like motor fault detection, doing that in real time. We also looked at high voltage to direct current conversion and get really, really fancy, great results in that area. And when we combine both signal processing and machine learning, advanced machine learning, we can win big challenges. We can win challenges that are international. 70 more teams from all over the world have participated, and we are proud to be number one of this challenge. And this was an example of a handheld ECG device where you put in your hand and we're measuring your ECG signal. And now I have a question for you. So who is from the audience, other than my good friend Yrjö, is using something from the 40s or the 50s? Still, probably not many, or probably none. Well, if you say no, then I would say, I guess you lie. Because if you're using neural network today, or any of the deep learning, then you are using the classical neuron model from the 40s. It was published in this paper by McCulloch and Pitts, a logical calculus of the ideas immanent in nervous activity, Bulletin of Mathematical Biophysics, 1943. So this is the crude approximation of that neuron where we have the modification of the input signal happening in the dendrites. These are coming from other terminal button from another neighboring neuron. And then the modified signals are summed up in the soma here with a summation function, very simple and crude one. And then this axon here, where the signal exceeds a certain threshold, then it will fire through an activation function. Well, this is crude, this is simple, and I'm surprised nobody thought about doing anything about it. So here's the MLP, the multi-layer perceptron model, that modifies those signal with some weights here, and then add them up in this pooling, the soma function, and activate them in case they are exceeding a threshold. So what we thought about is replacing the simple weighting function by a more complex function, phi, changing the pooling in the soma other than the summation by something more fancier. And we're keeping, of course, the activation function. However, we are choosing some good activation function that could work better for this problem. Well, we did the same thing for CNN, convolutional neural network that has sort of invaded the world. Deep neural network, deep learning is based on the convolutional neural network here on the left-hand side. But this neural network is using rudimentary convolutional kernels in here and summation in the pooling and then activation, as you can see on the left-hand side. What we thought about is instead of the simple convolution, we use a bit more sophisticated functions here, a bit more sophisticated function in the soma, and then some specific and suitable choices for the activation function. If we do that, we come up with a new neural network. We call it operational neural network. This is very recent stuff, guys, just been out in neural computing and applications. And now I'm going to show you some examples, some sort of known examples to him. And these examples are in the denoising area. So if you look at this signal, at these images on the left, these are the input. You probably cannot tell much, right? It's just the noise is too much. Also, same here. And then there's some famous people that CNN is really great. So let's use the CNN. This is the big deep learning things, you know. And this is the output of that CNN here also. You can see it there as well. So it doesn't show you anything, does it? Well, it doesn't, at least not to me. Well, we used our operational neural network and we started seeing something. This is heavy noise, by the way, but we started seeing something. The same here. So we see that there is a bus there, there is something there. And the target, the noise-free signal, is this one here on the right-hand side for both columns. If this is not clear, let me make this a little bit bigger. Again, that's the noisy part. You don't see anything inside. And here's what CNN, the famous deep learning, is doing. So those guys who are doing deep learning, be careful. And this is what we are producing from these. Really, really noisy. And this is finally the target. So we're not very far away. We are picking up the object. Again, not exactly noise-free, but it's doing really well. The next thing that, this is another set of examples for the test set, of course. But the thing that perhaps excites noise filtering and signal processing people are the gain in the loss or the gain in the SNR. So the decrease in the loss or the gain in the SNR. When you see a gap like this, exceeding 1 dB, you say, hey, I made it. I'm not 0.1 and 0.2 dB anymore. I really made it. I have a great gain. And when you see gaps like these, then you say, I truly made it, because then we're talking about 2 to 3 dB difference between what other people have done, even this CNN deep learning has done, and what we have done. So I think this is a good place for me to stop. But before I stop, I'm going to tell you a little bit of a story. So once upon a time when I was a little kid, I was wandering around in our neighborhood. It was a bit dark. I stumbled into something. I thought it was a stone. So I picked it up, I looked at it, and it doesn't look like a stone. It's something else. And I thought maybe I'll show it to my big brother, Yrjö. Maybe he will recognize that. So pay attention, Yrjö. Do you recognize what you see in this light? I hope you do. I don't hear you, but I hope you do. So happy and healthy life from all of us. And thank you for inviting me here.
Thank you, Moncef. Thank you, Moncef.
Thank you.
Now the next speaker is Olli Simula, Professor Emeritus of Computer Science and Engineering at Aalto University. In the 1970s, Olli worked as a research assistant and a doctoral student of Yrjö. Olli's main research topic was computationally efficient low-sensitivity digital filters. Olli, please.
Okay, so good afternoon, Yrjö and all the friends. I was given the title, which is shown here, Memories of Signal Processing Research with Yrjö. And that was a very good starting point for this talk. All happened quite nicely. I had just graduated in the early 1974, and Yrjö had returned from the US. And my professor Leo Ojala told me that there is a guy named Yrjö Neuvo who needs some help. And that's how we got to contact with Yrjö. And I started the doctoral studies under his supervision. And we both worked at the technical physics department at TKK. So, what is it? Now these slides are not in the proper order. But anyway. Okay. Maybe I pressed twice. So the main goals of the early research was design of computationally efficient digital filter structures, which means that we aimed at low coefficient sensitivities so that the filters could be implemented with a short word length. And then we tried to reduce the number of multiplications because that was the time-consuming and expensive operation at that time. There was also interest in the Finnish telecommunication industry in digital filtering, and the Televa Corporation was looking at touchstone signal detection using digital filters in 1975. And we thought that it's important to show that it is possible to implement digital filters and digital signal processing algorithms in real time, whatever is real time. And then we started the design of a hardware structure to show that these theoretical results we achieved in designing the transfer functions were possible to implement also using the technology of that time. So this is the front panel of our microprogrammable digital filter called NRS 290, where NRS stands for Neuvo Ropponen Simula, the design team, and 290 for the AM2900 circuit family, which at that time was the fastest microprocessor circuit family, and that was very good for DSP hardware at that time. Everything had to be built from discrete components. This processor contained 6 circuit boards. 3 of them are shown here. On the left, the multiplier, which is 12 bits, the word length. In the center, the input board, A to D converter, multiplexer, and on the right, the brain of the processor, the central processing element, and the data RAM. The design was quite tricky at that time. We built this hardware multiplier, and when it was ready, TRW introduced a single chip doing the same operation, but for a longer word length and the same speed. So our design objectives for this filter were high performance, ease of programming, which is a relative concept also, what is easy and what is not. The hardware was based on a modular filter structure, so that we defined in a microprogram module the basic filter structure, for instance, a second order block, and that module was then multiplexed to implement high order filters or even a filter bank up to 16 channels. The performance of the processor was quite good in our opinion. The datasheet said that we could achieve 230 nanosecond cycle time, and what we measured finally was 195. So it was faster than expected. And 6 years ago we wrote a paper together with Yrjö to a conference, Nordic conference on history of Nordic computing in Copenhagen. And when I prepared the paper for that, I was looking from the internet about the hardware implementations of the 70s, 80s, and I found a couple of reports reporting similar hardware based most likely on the same AMD circuit family, and the performance achieved was about 250 nanoseconds cycle time. So it really seems that we were on the top of the world. So the impact of this hardware project was quite important for the Finnish industry also. There were a number of students also in Helsinki and in Tampere who came in touch with this project, and we learned a lot from it, and that means that there was a quite a good expertise among the engineers in Finland at that time in the 80s, 90s, when the digitalization really started, and well, this figure shows some of the early phases of the work. Academic output was also important. As I said, I started as Yrjö's doctoral student 1974, and after he left to Tampere, I stayed. I spent a year in Delft, but finally the thesis came out, and Yrjö was really the instructor of my thesis. And as you can see, if you can see, the title of the thesis was directly from the design goals of our early research, design and implementation of efficient low sensitivity digital filter structures. There were several doctoral dissertations on digital filters at Tampere University of Technology in the early 80s. Some famous researchers mentioned here, Tapio Saramäki, Markku Reenfors, Kari-Pekka Estola, and so on. And I had some role in this work also. They were instructed by Yrjö, but I was the second opponent in many of these, for instance, in all these three defenses. Teaching came into the picture also in 1974. Yrjö started the first basic course on digital signal processing at TKK. The course was based on the classical book by Oppenheim Schäfer, or in fact on the manuscript of that book. The book came out in January 1975, but Yrjö had the manuscript from his time in the US, so that was used in the first course. And when Yrjö left to Tampere, I inherited the course. Of course, the book was changed several times during the development, but I continued the teaching of the basic DSP course until 2013. Nordic cooperation in education and research was very active in the 70s and 80s. Yrjö was one of the initiators of that activity. We had good colleagues in Linköping and Trondheim. We organized several symposia, conferences jointly, and even Nordic doctoral courses on DSP algorithms during that time. Just to mention, the first international symposium I attended together with Yrjö was in Stockholm 1974 in April. I presented my first paper there with a very, very nice environment. There were invited speakers from US, James Cooley, the inventor of the FFT algorithm, Teuvo Kohonen, the pioneer of neural networks from our lab, technical physics, and then Jorma Rissanen from IBM, who is one of the pioneers of information theory. And the highlight of the conference organization was, of course, ISCAS 88, held in Helsinki. Yrjö was the general chair, and he did a great job in getting the conference to Finland. And later in the 90s, we heard in one of the ISCAS conferences that they had in the US then the largest ISCAS ever, if Finland is not counted. So we had 1,100 participants in this conference, which was quite a number. So to conclude, it has been a pleasure to be your student, your co-author, and to cooperate with you in form or another throughout my career. And in the early days, it was really nice to be on the top of the world. Thank you.
Thank you, Olli. Now we move from research to research and innovation policy and to national and international programs. The first speaker in this theme is Professor Marja Makarov. Professor Marja Makarov chairs the Technology Academy, which awards the €1 million Millennium Technology Prize. And she was the vice chair of the founding board of Aalto University. Marja Makarov is a member of the European Innovation Council and a former board member of the European Institute of Innovation and Technology, EIT. Marja's topic today is research and innovation policy at national and European level. Marja, please.
Thank you very much. Dear Yrjö, ladies and gentlemen, my topic is Yrjö and innovation policy, and let me start with a fast-track flash of national innovation policy that we did together with Yrjö during a taxi ride in Helsinki. So we met for the first time in 2005 in an event which dealt with doctoral training, and we shared a taxi on our way back home, 15 minutes. Yrjö mentioned that in the research, in the Nokia Research Center, they are really lacking expertise of fundamental mathematics, and they do not have any contacts with pure mathematicians. I was at that time vice rector of the University of Helsinki and had encountered the problems in the Kumpula campus with mathematicians, the department. There was no attraction for anybody else but wannabe Fields medalists, the Nobel Prize of mathematics. So, what did we do? We decided to put together in one room the Nokia Research Center guys. This was Yrjö's task, and then I attracted the pure mathematicians of the Kumpula campus. What was the result? They got together, they spent 3 hours together, they came out with shining eyes. The Nokia guys realized that fantastic mathematicians, pure mathematics, exactly what they need for the very futuristic ambitions. And the Kumpula guys said that, wow, the guys in Nokia, their ambitions are really high, and this is extremely interesting for fundamental mathematics. So the impact was, for the University of Helsinki, that the two parties got together, they designed a joint research program which was funded by Teknologiateollisuuden 100-vuotissäätiö, the Centenary Foundation of Technology Industry. And then, pretty soon thereafter, on the Kumpula campus, an industrial mathematics program was established, and this attracted the best mathematicians in the country, and applications started to come out. Now, mathematics and mathematicians really were fertilizing the Finnish society in different sectors, not only in the industry, with mathematics expertise. Now, let me jump to the European level. So, the European Institute of Innovation and Technology, the EIT, now 10 years in operation. Yrjö was member of the founding governing board of the EIT. And this was a totally new idea of cross-border collaboration, now taking advantage of research findings which were brought then to the use of society, translation of research findings into innovation and business and jobs and growth. So Yrjö worked, I think, from 2008 to 2012 in the board, and this laid the foundations for the EIT. And the mission is really to translate Europe's research strengths to growth by creation of ecosystems, and these ecosystems now all across Europe enhance companies' access to talent and innovation know-how, to partners and market opportunities. And the EIT also drives what is called the knowledge triangle, and in the knowledge triangle, education, higher education, research and then business work together, and they are interconnected. Now I will show you what the EIT is today, and this is all now the result of Yrjö et al. Who started this business in the founding governing board. Now the EIT today covers all of Europe. It works as thematic knowledge and innovation communities, so-called KICs. And each KIC has a headquarter and 3 to 5 nodes, all in different European countries. Finland is attached to many of these. Aalto University, I think, is operating in 3 of these KICs. Many other companies and universities in Finland as well. And now it is the European Parliament which decides on the themes, and they are very, very relevant. So the EIT KIC themes are in the areas of climate, digital, food, health, manufacturing, energy, raw materials, and now there's a 9th, a new one coming up, and it is just waiting for the final decision of the European Parliament, and this is very interesting as compared to the earlier ones, and this is culture and creative industry. And you can see on the map the distribution of these innovation hubs of the EIT, which now amount to almost 70. Now, after 10 years of consolidation of the EIT concept and its implementation, there's a new kid on the block, and this is the European Innovation Council, the EIC. The EIC will be a fully fledged program with probably its own agency, which will have in Horizon Europe budget 10 billion euros, plus the ambition is to gather 50 billion more, which will be now invested into the EIC fund, and this is now private money. And this is to support deep tech breakthrough technologies. There are 2 main programs. One is the Pathfinder program, which is for researchers on deep technology, academics. And the other one is for SMEs, startups and small and medium-sized enterprises. The researchers can apply for a grant up to 5 million euros. The SMEs can apply for a grant, which doesn't have to be paid back, up to 2.5 million euros, plus equity up to 15 million euros, and then more money into the equity from the EIC fund. And now this money goes to individual researchers, individual SMEs. And how do then the EIT and the EIC work together? These awardees of the EIC program now have the EIT's ecosystem at their disposal with 1,500 partners, which is large companies, medium-sized companies, startups, it is universities, and the 70 top universities of Europe are partners, plus cities and research. And the joint mission really is to translate research findings into jobs and growth, economic growth of Europe. So, Yrjö, thank you so much for your contributions. They have been absolutely essential, also at the level of innovation policy in Finland and in Europe, probably also beyond. And thank you for your contributions. And I must say, Yrjö, that you are an absolutely charming, no problem, solution-oriented person. Thank you.
Welcome back from the break, and let's first check the poll results. So it seems that almost half of the audience have known Yrjö for 20 between 40 years, but there are 2 people who have known Yrjö for more than 60 years. Now, in the next talks, we will continue on the theme of national and international programs to increase competence. Yrjö has been a key figure behind many such programs, either in education, research, technology, or in innovations. And he has left his mark in the careers of hundreds of people. At Aalto University, a famous course named BitBang was run for several years by professors Yrjö Neuvo and Erkki Ormala. The course was meant for doctoral students, and its aim was to promote industry-academia collaboration, multidisciplinary teamwork, and global perspectives. One BitBang course alumni will now share his memories on the course and how it shaped his personal career. His name is Vincent Kuo, and he is now a startup founder. Vincent's company is called VXT, and its expertise is in text analytics. Vincent, the floor is yours.
Thank you very much, Elle. Yes, a very, very warm welcome from my side to all of you, especially joining us online, fellow speakers here in the studio, and a special shout out, of course, to all the other BitBang alumni. I know that the talk will be just the tip of the iceberg from my side, but I hope that I could give the alumni also a little bit of voice. So I thought to start with what you may already know about BitBang. And BitBang consists of basically 3 main components as an executive doctoral course consisting of an international excursion. There you see in the picture Yrjö on the right hand side. So that picture is taken at the Design Factory in South Korea. Executive lectures from industry, researchers, research institutions, governments and the like, resulting in a foresight-based publication on the topical issues in digitalization. I thought to today take you down memory lane and to look at a couple of the smaller things, the wisdoms and the anecdotes that had came from BitBang that had helped me with my transition from engineering to research to business, now most recently, and hopefully that could give you some food for thought and maybe something to laugh about or think about. So my BitBang journey began in 2014, and this picture that you see here is taken in Tongji University. It's the 7th installment of BitBang. You see Yrjö there with his monkey, and me right behind him, and Professor Erkki Ormala, who is the co-professor in this particular course. And what I'd like to highlight in this particular picture is the diversity. That's the middle name of BitBang. That's the forte of BitBang, the multidisciplinarity and diversity. And it doesn't come without challenges. And I'd like to shed light on what that means for engineering. The challenge in diversity is knowing what you know and knowing what you don't know, as well as trying to uncover what you don't know that you don't know, and what you don't know that you know. I guess I've handled that. And in this process of collaborating and deliberating and arguing, I have distilled an insight that I thought could be has helped me a lot, that I might share with you, and that is that we all ought to learn to ask more stupid questions in one way or another. And I have experienced so that the stupid questions are the ones that uncover, that build bridges between multidisciplinary groups without the pressure and without the judgment. So that's the first one. Fast forward a year from then, this is a picture taken at what we call the BitBang seminar. So accompanied with a publication is a seminar that's presented in this particular case at the Aalto Festival. What was so distinct about this memory for me was the fact that our audience was actually high school students. Yrjö, you may remember that. And that was probably by far at the time, maturing as a researcher and thinking, into the depth of the topics, it was an extremely valuable experience to think, how do we communicate these to people in high school? And the response from the high schoolers was nothing less than inspirational, the questions that they asked and so on. On a little similar note, this is a picture taken in South Korea on one of the international excursions. We were walking around a historical area and we came upon two young children, these two kids that you see in orange, if they're not obvious, and they were volunteering to be tour guides for people who they meet randomly. And upon hearing this girl, at least upon hearing that we were PhDs, so she was so absolutely starstruck, you know, and that's a glimpse of, you know, outside of the bubble for us of doctoral studentship and being all the time caught up within our own communities, to understand the privilege and in some ways the responsibility as well that we have towards being role models for people who may be younger. And this has been one of the most humbling experiences, at least that I have taken away from this trip. So the other anecdote, or let's say wisdom, is that one ought to try and get feedback from children about your research, if you are a researcher, or otherwise. This has shaped my doctoral research, as well as so to say, my doctoral defense. I think that those who've seen the defense can see a little sprinkle of BitBang in the presentation done there. Moving along, the other big pillar of BitBang is the engagement with industry. And this is a picture taken when we visited Valmet in China in 2015. An example is Kone. This is also in China, outside of Shanghai. We get a view of their workshop from this view. You can see the whole process. Very inspirational to see Finnish engineering being contextualized, and Finnish engineering business of all being contextualized in many different parts of the world. This is a picture of Heikki Ranta from Cargotec telling about lean using a sword as a prop, and you see there Erkki and Yrjö taking notes. This is another example taken at Nokia in South Korea, and this is a luncheon at the Chamber of Commerce in 2016, where Yrjö is saying a couple of words. So all of these memories, what I can distill is that learning about the global engineering business ecosystems, the governments, the third sector, how they interact with one another, has been, for me, one of the strongest driving forces towards entrepreneurship, and to think in the entrepreneurial mindset. And I would encourage you also to keep your eyes and ears open for these types of learnings. I would like to close off now by saying, Yrjö, thank you very much for BitBang, these priceless memories. Thank you for EIT. I have been lucky enough to be Yrjö's student. And an absolute honor for me to stand here today to be a little voice on behalf of the BitBang community. And above all, thank you for the inspirations. Cheers. Thanks, Elva.
Thank you, Vincent. Another student of Yrjö is Dr. Kai Öistämö, with whom Yrjö has conducted signal processing research at Tampere University of Technology. Kai and Yrjö have published several papers, especially on image processing and video signal processing. And Kai was also Yrjö's colleague during Nokia times. Kai has a few days ago started as the Chief Executive Officer of Vaisala, so congratulations on your new position, and the floor is yours, Kai.
Thank you very much, and thanks for the opportunity to speak to you on a very exciting topic. The topic of the speech was how studies in signal processing has shaped my career. And when I thought about what to speak of, I kind of, first of all, as I've studied engineering, I took it literally. So it's really about, so what's my career and how has it been shaped by the studies. So just what did I study? So first of all, I met Yrjö. I was looking for I was end of the third year, and I was looking for a Master of Science thesis work, and I had heard about this excellent kind of research laboratory and of signal processing in Tampere University, and I sought for a short introduction to Yrjö, met him, and asked if I could join and do a master's thesis. So I ended up doing, and it was on then a completely new topic, which is nonlinear signal processing. First on median processing on still images, or as a master's thesis, and then once I did that, then I was thinking about whether I should actually go to a real job or whether I should continue my studies at the Yrjö's lab, and decided it was not much of a thinking, much of that hard of a decision. So decided to continue and then continue as a PhD studies, and then a little bit more complex. So it got three-dimensional, so it's a vector median processing of video images. So there was a kind of a two-dimension, one dimension on the vector side, on the media side, and one dimension more on moving images instead of still images. And so that's and post that, then I actually, at the very end of the studies, I already decided to join Nokia. That time it was a consumer electronics side, which was then actually doing televisions. For those who are younger, don't necessarily remember, but that was then the biggest division in Nokia, and supposedly the growth area of the future. So there I went, and the first job really was actually taking the algorithms that we had developed during my PhD thesis and actually turn them into an actual real product. So taking that algorithm, simulate it into such a way that it actually would fit into a TV context, and then take it into actually on a signal processing chip on silicon to be introduced in upcoming HD TV products. Long story short, the HD TV didn't happen. And the chip itself did happen, but it really didn't have much of a success. Then after that, I joined mobile phone side of Nokia. Actually, after consulting Yrjö, who had already by then joined Nokia, I actually was one of the very few people that I was abroad, and I made a call back to Finland, and I had decided to come back, and I was wondering, it was time of the recession in Finland, and it was not an easiest thing to find a job. And I was wondering that any leads, any kind of good ideas where somebody like myself could find a good job. And I guess I hadn't made a completely bad impression during my studies, so I think I got kind of a little bit of a introduction through Yrjö. And so I got a job, this time as a product marketeer, and this actually is kind of a first kind of a reference back to the studies, how they actually shaped my career. So obviously the first step was pretty much of a linear step. Many people have done this. This was a side step, and actually during my studies I had all along studied not just the signal processing, but industrial economics. And I remember having a discussion with Yrjö after the master's thesis was done, and we were considering whether I should continue on the on the PhD side, and the discussion went something like that he was challenging me that, are you really serious about this, since you are studying all this economics side as well? And I convinced that it's a good idea, and so I did, and then that actually came to play on the next big part of my career at Nokia, and then post that actually as a private equity, kind of I worked for a private equity company post Nokia as well. So big part of that was there. Then the next side of the signal processing complex thinking was I joined a company called InterDigital, which is actually doing basic research. It was like going back to the roots and very much of a signal processing side, mobile, kind of a mobile algorithms, and so on. I still was more on the management and kind of commercial side, but very much of a kind of needed to understand, and there certainly having kind of the three-dimensional vector media and moving images capability helped me quite a bit. And the other thing, which is actually kind of an interesting coincidence, and I'll come back to this a little bit later, touch upon this a little bit later as well, was that during my studies, where we were a very international group, as we've heard already today, and it was lots of cooperation around the world. One of the places where we actually visited and had a cooperation was a University of Rennes, which happens to be a cousin city for Tampere, and we actually, in InterDigital, we actually bought the video research at Rennes. So I had at least lots of street credibility of actually having been there more than 20 years before, visiting the laboratory, having done a PhD in video processing, and it worked out actually great. And now, as you heard, the latest job is at Vaisala. Now, it's not so. Then going back to the topic. So how did my studies in digital signal processing impact my career? I think even more when I reflect back, it's more than the digital signal processing side. It was actually the studies side that impacted my career. And then I go back on how was the research group that Yrjö had in Tampere. The first thing I would bring up is it was international. The ambition level was to be the best in the world. It was not local. It was not best in Finland, but it was global. All the collaboration were around the world, and for a 20-some-year-old, it actually was a kind of eye-opening on raising the bar and thinking about the world completely differently than what one would have thought otherwise. The other thing is the international team, the nature of the team, and at that time, living in Tampere, that was not the norm. I tell you that it was having an environment where it was top of the class of people from around the world, working language English, and it set the tone on how I perceived the world. Second thing I would bring up is selecting the team, building the team, and creating a team. Team is much stronger than an individual. I don't think I would have made PhD ever without the research team, and that kind of second learning was team is much stronger than an individual. Third thing would be leadership. Lead by example, lead by questions. So Yrjö was genius actually. Whenever I had a technical trouble, he never gave me answers, but he always knew what were the right questions. And I think that was much better than giving the answers, and not everybody can do that. Then creating the right environment to succeed. It's bringing the right people, setting the right bar. It's about the leadership, but it's also about the atmosphere. It's about creating the enthusiasm and the curiosity that many people have talked about today. It's also about creating fun and a place where you want to be. And when I reflect back on my career, these are actually the things that have shaped my career probably even more than the topic that I studied. And these are the things that I have tried to carry with me. And I still, it's like having a management training program in the laboratory when I worked there. And it has been a privilege. I really thank you for Yrjö for all that. And I continue to be very, very thankful.
Thank you so much, Kai. Our next speaker is Outi Krause, Emerita Professor at Aalto University School of Chemical Engineering. Outi is a board member of the Finnish Foundation for Technology Promotion, in Finnish TES, Tekniikan edistämissäätiö. And she is also a board member of Foundation Joint Effort, the Postdoc Pool, and a board member of Postdocs in Companies Podoko. Podoko is a joint initiative of Finnish universities, industry and foundations, and it's innovated by Yrjö. In the Podoko program, a young doctor gets foundation funding for research, and after that the company hires the postdoc to deepen the research results and to create company-specific insight. And now I will hand over to Outi.
Thank you very much, Ella. First of all, I want to thank the organizers for inviting me to deliver this talk. Dear Yrjö, I feel really honored to be here to greet you and tell about one of your initiatives, the Postdocs in Company or Postdocs Meet Companies program. I don't remember, or maybe I even don't know, when everything began. But in any case, I know that when you chaired the Finnish Foundation for Technology Promotion, TES as we call it, you were interested in education of doctors and concerned about the employment of young doctors, especially of international doctors in industry. You were also concerned about the impact of the foundation. In 2011, you proposed that the foundation should organize a workshop to discuss how to improve the impact of a small foundation such as TES. You summarized the results of the workshop by asking some questions such as, in what ways should the cooperation between the foundations be promoted? Would it be possible to broaden the operation such as a postdoc pool? Could it be that in these questions the seeds of the program Postdocs Meets Company were shown? To combine cooperation between the foundations with the employment of young doctors? Maybe. In any case, in 2014, you wrote a document, Long-term consolidation of Finland's competitiveness towards a better encounter between young researchers and business, in which you crystallized the idea of the postdoc pool. But what is a program Postdocs Meet Companies? The program was initially a joint initiative of the Finnish universities, industries and foundations. Nowadays it is much more extensive, including also companies outside the industry. The aim of the program is to facilitate contact between postdocs and companies and offer a young doctors an academic research period followed by a targeted research period lasting between 1 and 2 years. The research should have strategic importance for a Finnish company. First part, meant for the academic research, is funded by a grant from one of the foundations participating the program. The length of this phase is between 6 and 12 months. After the research period, the company hires a postdoc for an equal long period as the first part. During that time, the postdoc deepens the research results by creating company-specific insights. This results a win-win situation. The academic research supports companies and the young doctors get industrial experience. You, Yrjö, spent countless hours to convince various foundations of the new program and of its high importance. By 2015, 3 foundations had committed to join. And when the Technology Industries of Finland Centennial Foundation decided to support the launch of the program, the first application round was organized 5 years ago, in autumn 2015. In December of the same year, 9 grants could be awarded. In the 10th application round last spring, 17 grants were awarded by 9 foundations, and a vast range of companies was covered, from large to a small spin-offs, and from 9 waste to urban lifestyle engineering. Feedback from our grantees has typically been very positive. Let me give you one example. I quote, the PODOCO grant definitely influenced the direction of my career. Without the program, I would possibly have tried to continue in academia, at least for a while. But now I can contribute to the business with the research knowledge I have acquired. In addition, that doctor was hired permanently by the company to continue the work. Unfortunately, not all the grantees have been so lucky. In spite of the high expectations, some companies, especially more ones, have not been able to hire the grant holder. The growth of a postdoc in companies has been remarkable. A totally 11 foundations are now committed to the program. The PODOCO Management Group is responsible for the program. The group consists of representatives of each foundation. Yrjö has been the chair of the management group from the very beginning. DIMECC, the innovation platform in the Finnish manufacturing industry, is responsible for the practical implementation of the program. Yesterday, I got a message saying that in the 11th application round, we have received 34 applications, 6 more than in the spring. Share of the small and medium-sized companies was high, 88%, as it was in the spring. PODOCO goes strong. Thank you very much, Yrjö, for creating this splendid postdocs in companies program. Thank you.
Thank you, Outi. And at this point, the language of the event will change to Finnish. Eli seminaari jatkuu tästä eteenpäin suomen kielellä. Aiheenamme on edelleen tiede- ja innovaatiopolitiikka. Olemme tähän asti kuulleet erilaisista osaamisen kehittämisen hankkeista Suomessa ja kansainvälisesti. Näkökulmamme on vaihdellut yksilötasolta instituutiotasolle. Ja jatkamme samasta teemasta, kun tohtori Pirjo Kutinlahti tulee kertomaan kansallisesta osaamiskeskusohjelmasta. Pirjo Kutinlahti on neuvotteleva virkamies työ- ja elinkeinoministeriössä ja hän oli osaamiskeskusohjelman pääsihteeri vuosina 2007-2013. Ja tällä hetkellä hänen vastuullaan työ- ja elinkeinoministeriössä on kansallisen innovaatiopolitiikan suunnittelu ja toimeenpano. Ole hyvä, Pirjo.
Kiitos. Hyvä Yrjö, arvoisat kuulijat. Alueellisen innovaatiopolitiikan lippulaiva osaamiskeskusohjelma, eli lyhyesti OSKE, on ollut merkittävä osa suomalaisen innovaatiopolitiikan historiaa. Osaamiskeskusohjelma käynnistyi vuonna 1993, jolloin Suomen talouden tilanne oli vähintäänkin yhtä haasteellinen kuin tänään. Tuon ajan päättäjillä oli kuitenkin usko tiedon, osaamisen ja innovaatioiden merkitykseen kilpailukyvyn ja talouskasvun turvaamisessa. OSKEn käynnistäminen olikin yksi osa laajempaa hallituksen talouspakettia, jonka pohjalta Suomi nousi 2000-luvulla yhdeksi maailman kiinnostavimmiksi innovaatiomaaksi. Ohjelman ensimmäiselle kaudelle valittiin 8 osaamiskeskusta. Vain suuret kaupungit pääsivät mukaan. Viimeisellä 3. ohjelmakaudella mukana oli jo 22 alueellista osaamiskeskusta ja kaupunkiseutua. Ohjelmaa johdettiin laajapohjaisen eri ministeriöiden, yritysten, korkeakoulujen ja alueiden edustajien muodostaman työryhmän johdolla, jonka puheenjohtajaksi kutsuttiin professori Yrjö Neuvo. Toisin kuin kansalliset TKI-rahoituksen välineet, OSKE asemoitiin alueellisen innovaatiotoiminnan kehittämisen välineeksi. Ja siihen valikoitui kilpailun kautta kaikkein kehityskelpoisimmat kaupunkiseudut. Tuolloin edistyneimmät alueet kirittivät kehittymässä olevia ja päinvastoin. Käytännön toiminnasta vastasi useimmiten paikallinen teknologiakeskus, joskus myös korkeakoulu. OSKEn vahvuutena oli ennen kaikkea sen vipuvaikutus alueen tutkimus- ja innovaatiotoimintaan. Varsin pienellä julkisella rahoituksella saatiin käynnistettyä mittavia kehityshankkeita alueen yritysten, korkeakoulujen ja tutkimuslaitosten kanssa. Nämä puolestaan lisäsivät alueen elinvoimaisuutta ja kilpailukykyä sekä loivat osaamispohjaisia työpaikkoja. OSKEn myötä alueet erikoistuvat omille vahvuusalueilleen ja työnjako eri alueiden välillä parani. Suomeen alkoikin hiljalleen syntyä kansainvälisesti merkittäviä kasvukeskittymiä. Ohjelmasta hyötyivät niin isot kaupungit, mutta etenkin keskikokoiset ja pienet kaupunkiseudut. Seuraavassa kerron teille 3 menestystarinaa. Ensiksi katse kohti Suomen länsirannikkoa Vaasaan. Vaasan seudulle on kehittynyt Pohjoismaiden suurin energiateknologian keskittymä, jossa kehitetään älykkäiden sähköisten ratkaisujen, kestävän energian ja joustavan sähkön tuotannon ratkaisuja. Vaasa ja sen energiakeskittymä onkin viime vuosina ollut yksi Suomen kiinnostavin työ- ja harjoittelupaikka tekniikan opiskelijoille sekä alan insinööreille. Seuraavaksi siirrymme Suomen metsä- ja biotalouden keskittymään Joensuuhun. Pohjois-Karjalaan ja sen keskuskaupunkiin Joensuuhun on viimeisten vuosikymmenen aikana syntynyt ainutlaatuinen biotalouden osaamiskeskittymä. Alueen profiloitumista tukevat vihreän kasvun osaamiskärjet, kuten ICT, fotoniikka ja kemian materiaaliosaaminen. Ja tällä hetkellä myös fotoniikan yritystoiminta on siellä vilkasta. Lopuksi vielä kurkistus kohti kehittyvää kasvukeskusta Kajaania. Mittaustekniikkaa on kehitetty pitkäjänteisesti 90-luvun lopulta alkaen alueen osaamisperustaisen elinkeinopolitiikan kärkenä. Ja tekoälyn aikakaudelle siirtymistä vauhdittaa nyt Kajaanin rakennettava ja maailman kärkeä oleva Lumi-supertietokone. Sen ympärille on rakentumassa suurteholaskennan ekosysteemi, jonka hyödyt voivat olla Suomelle ja Euroopalle vähintäänkin yhtä merkittävät kuin elektroniikan kehitys aikanaan Nokia-klusterille. Hyvät kuulijat, osaamiskeskusohjelma on kiistatta kansallinen menestystarina, jonka vaikutukset näkyvät tänä päivänä innovaatiotoiminnassamme. Nykyinen osaamispohjainen talous ei olisi syntynyt ilman pitkäjänteisiä investointeja tutkimukseen ja innovaatioihin. Oskessa omaksuttu kehittämisen malli herätti myös suurta kiinnostusta ympäri maailmaa, ja tuskin liioittelen, jos väitän, että nykyinen EUn älykkään erikoistuminen strategia olisi perua suomalaisesta osaamiskeskusohjelmasta ja sen kehittämismallista. Menestystarinoiden rinnalla alueet ovat joutuneet kohtaamaan myös talouden äkillisiä rakennemuutoksia. 2010-luvulla koettu IT-alan rakennemuutos koetteli erityisesti Tampereen, Jyväskylän ja Oulun seutukuntia. Muutamassa vuodessa kuitenkin nämä paikkakunnat selviytyvät iskusta ja uusia yrityksiä alkoi syntyä. Kolmas ja viimeinen toimintakausi nosti esiin erityisesti klusteri- ja toimialapohjaisen kehittämisen, jolla vahvistettiin myös alueiden keskinäistä yhteistyötä. Sanoisin, että osaamisklusterit, shokit olivat esiaste nykyiselle ekosysteemitoiminnalle ja ekosysteemipolitiikalle. Hyvä Yrjö, juhlayleisö. Osaamiskeskusohjelma muutti ratkaisevasti Suomea. Alueet ja sen yritykset oppivat investoimaan osaamiseen ja innovaatioihin. Hajallaan olevaa osaamista koottiin isommiksi kasvukeskittymiksi ja yhteistyö yritysten ja korkeakoulujen välillä tiivistyi. Ja lopulta myös kaupungit oppivat tekemään yhteistyötä keskenään. Ratkaisevaa ohjelman menestymiselle oli se, että sitä johdettiin alueiden omia valintoja kunnioittaen. Yrjö Neuvon henkilökohtainen sitoutuminen ja visio osaamispohjaisesta Suomesta ja sen alueista on tunnistettavissa ohjelman strategisissa periaatteissa. Näitä olivat: toiminnan laadusta ei tingitä, kehittämiseen sitoudutaan pitkäjänteisesti ja tuetaan yhteistyöhön kykeneviä kehittäjäyhteisöjä. Hyvä Yrjö, uskon edelleen siihen, että Osken kaltaiselle ohjelmalle olisi tarvetta myös nykyisessä toimintaympäristössä. Kansainvälinen kilpailu TKI-toiminnan sijoittumispaikoista ja osaajista on kiristynyt entisestään. Suomi tarvitsee lisää kansainvälisiä osaajia, ja tämä voi onnistua vain sillä, että meillä on riittävän innostava ja houkutteleva toimintaympäristö niin tutkimukselle kuin uudistushaluisille yrityksille. Kiitokset.
Kiitos Pirjo. Seuraavana Martti Häikiö. Professori Martti Häikiö on historian tutkija, joka on kirjoittanut paljon historiikkeja yrityksistä ja ihmisistä. Tampereen teknillisen yliopiston historiikkia tehdessään Häikiö otti yhteyttä Yrjöön, koska kuulemma Yrjöä koskevaa materiaalia oli kertynyt niin paljon. Ja näin syntyi kirja Bit Bang, Yrjö Neuvo ja digitaalinen kumous. Sen ovat toimittaneet Martti Häikiö ja Essi Ylitalo. Annan puheenvuoron Martille.
No niin, terve Yrjö ja hyvät digikumouksen ja suomalaisen huippututkimuksen ystävät siellä ruutujen äärellä. Mä olen siis historian tutkija ja tutkin parhaillaan teknologista kaksoisvallankumousta. Se tapahtui joulukuussa vuonna 1877. Suomen ensimmäinen sähkövalaistuskokeilu toteutettiin Valtionrautateiden konepajalla ja ratapihalla Helsingissä 10. joulukuuta 1877. Muutama päivä tämän jälkeen Metallitehtailija Juhan Nissinen yhdisti Helsingin Annankadun ja Eerikinkadun kulmassa olevat konttori- ja myyntihuoneistot pihan yli kulkevalla puhelinjohdolla. Ensimmäisen johdon päässä oli 2 puhelinta, joissa ei ollut mikrofonia. Daniel Johannes Wadén, jonka elämäkertaa kirjoitan, oli tämän kaksinkertaisen teknologisen kumouksen uranuurtaja. Wadén rakensi Helsingin ensimmäisen sähkölaitoksen Pohjois-Esplanadille ja Wadénista tuli Suomen puhelintoiminnan isä. Mutta en nyt puhu Wadénista, vaan Yrjö Neuvosta. Yrjö Neuvo on reilut 100 vuotta myöhemmän teknologisen muutoksen, digikumouksen keskeinen näkijä, tekijä ja vaikuttaja. Tutustuin Yrjöön, kun kirjoitin Nokian historiaa 1990-luvun lopulla. Mutta varsinaisesti törmäsin hänen giganttiseen, tai pitäisikö sanoa gigabittiseen, rooliinsa kirjoittaessani Tampereen teknillisen yliopiston historiaa. Digitaalinen signaalin käsittely ja Yrjö Neuvon rooli siinä oli niin suuri osa titityyksi kutsutun korkeakoulun tarinaa, että oli luontevaa kirjoittaa se omaksi tarinakseen. Tässä kuvassa näkyy maisteri Essi Ylitalon kanssa kirjoittamani Yrjön elämäkerta, joka ilmestyi vuonna 2013. Tässä esityksessä koitan hahmottaa, miten tutustuminen Yrjö Neuvoon on mitä se on minulle opettanut teknologisen muutoksen dynamiikasta. Ensimmäinen ja toinen ja viimeinen havainto Yrjöstä on, että hän on ollut keksijä ja kokeilija koko elämänsä, niin lapsena kuin harmaahapsena. Hän on rakentanut kidekoneita, kohta puhuvan Matti Kuusimäen kanssa. Hän on ollut kehittelemässä minitraktori Avantia, näkyy tuossa kuvassa keskellä, jonka kyydissä Essi sai olla Raaseporin huvilalla, kun Yrjö esitteli metsurin taitojaan. Yrjön perusominaisuus on, että hän on tarttunut uteliaalla leikkimielisyydellä uusiin asioihin. Sen symboli, suorastaan tavaramerkki, on hänen ihmesalkkunsa tuossa kuvassa oikealla. Yrjö on sanonut vuonna 2005, pitää olla uusille asioille herkkä, kokeilla erilaisia vaihtoehtoja. Uuden kehittäminen vaatii ennakkoluulottomuutta, positiivista katsomista eteenpäin, eräänlaista leikkimielisyyttä. Onnistumisen todennäköisyys kasvaa, mitä fanaattisemmin siihen panostaa, sitä enemmän panee itsensä likoon innolla ja ihastuksella. Saman asian hän ilmaisi äskeisessä juhlaluennossaan englannin kielellä. Toinen havainto on, että Yrjön uralle sattui onnekkaasti digitaalisen signaalin käsittelyn läpimurto tieteen maailmassa. Hän oli ensimmäinen tästä uudesta ilmiöstä lisensiaattityön tehnyt insinööri Suomessa. Aiemmissa esityksissä on käsitelty Yrjön tieteellistä uraa. Totean vain, että hän nousi Suomen tieteen korkeimmalle korokkeelle. Hän sai Suomen Akatemian pysyvän tutkijaprofessorin viran. Tässä Yrjö seurasi äidin isäänsä Yrjö Väisälää, tähtitieteen ja geodesian maailmanluokan tutkija ja tutkimusvälineiden rakentaja. Yrjö Väisälä oli akateemikko. Silloin se vielä oli virka, eikä vain arvonimi, kuten nykyään. Presidentti Urho Kekkonen hän voimansa tunnossa lakkautti niin sanotun vanhan akatemian ja akateemikkojen virat. Saimme käydä Yrjön ja Tuulan kanssa Yrjö Väisälän kotipesässä Tuorilan observatoriossa, joka nyt pyritään pelastamaan tieteen historialle ja uuden luomiselle. Todella hieno ja tukemisen arvoinen paikka. Mieleeni jäi tapa, jolla Yrjö kuvasi hyppyään tieteen maailmasta teollisuuteen. Hän oli toki tehnyt paljonkin yhteistyötä teollisuuden ja Nokiankin kanssa. Kun Nokian toimitusjohtaja Jorma Ollila soitti ja kutsui häntä kokopäivätoimisesti töihin Nokian teknologiajohtajaksi. Tiedemaailmassa viihtyvää Yrjöä hyppy teollisuuteen arvelutti. Yrjö sai rohkeutta henkilökohtaisen uran loikkaan muistaen tätiään matikan opettaja Marja Väisälää. Marja täti oli uskaltautunut lähtemään turvallisesta suomalaisesta lähetyskoulusta mustien opettajaksi viidakkoon. Jos kerran Marja täti uskalsi lähteä, niin kyllähän minäkin voin tämän loikan tehdä. Yrjö perusteli tiedemaailmasta lähtöään Nokialla. Nokian teknologiajohtajana Yrjö saattoi jatkaa leikkimielistä kokeilu- ja kehittämistyötä. Nyt vielä huikeasti suuremmin resurssein ja konkreettisemmin päämäärin. Hänen omaperäinen tyylinsä tarttui tutkimuksen ja tuotekehityksen henkilökuntaan, mistä tämä hänestä teetetty kuva kertoo. Yrjö sanoi lukeneensa kaikki Potterit ja vieläpä alkukielellä englanniksi. Minäkin luin jopa yhden Harry Potterin, tosin perehtyäkseni hänen mielenmaisemaansa. Ydinteemana oli Unfogging the Future, eli sumean tulevaisuuden aavistaminen. Todellisena sumean tulevaisuuden aavistuksena voi nähdä tämän kuvan vuodelta 1994, tai piirtoheitin kalvon, kuten niitä silloin sanottiin. Yrjön elämäkerran tekemisen ytimessä oli yritys ymmärtää digitaalisen kumouksen luonnetta. Huomatkaa, että tämä kuva on esitetty jo ennen kuin kännyköistä ja tableteista tuli jokamiehen taskutietokoneita. By the way, Electronic Pocket Office olisi hyvä brändi tänäkin päivänä. 2 vuotta myöhemmin, vuonna 1996, Yrjö visioi. Puhelin, tietokone, televisio ja video kietoutuvat yhä tiukemmin yhteen. Näin hän kertoi Iltalehden 4 sivun jutussa. Digitaalinen signaalin käsittely mahdollisti kokonaan uusia ennalta arvaamattomia ominaisuuksia ja toimintoja. Puhelin muuntui monipuoliseksi hyödyn ja huvin välttämättömäksi välineeksi. Matka Bellin ja Wadenin puhelimista tulevaisuuteen oli saanut digitaalisuudesta huiman boostin. Sivumennen on kyllä pakko sanoa, että pidän tätä 1870-luvun kumousta vielä suurempana ja merkittävämpänä kuin tätä meneillään olevaa digikunousta. Sähkö- ja tietoliikenne, puhelin tulivat silloin. Tässä ohimennen kuva vuodelta, jossa visioidaan uutta tulevaisuutta erittäin toteutuneella tavalla. Se oli 96 tuo visio nähtiin ja oikealla on puhelin, jossa on kosketusnäyttö ja käsialasta tunnistava kirjoitus. Sehän on toteutumassa ilmeisesti näinä aikoina 16 vuotta tuon kuvan jälkeen. No niin, lopuksi yhteenveto. Tutustuminen Yrjöön on ollut matka teknologian kovaan ytimeen tai pehmeään, miten sen kukin kokee. Koitan tiivistää lyhyesti, mitä olen oppinut tällä matkalla Yrjöltä. Mikä on se big picture? Mielestäni on 2 kuvaa. On vertikaalinen syvyysakseli, eli pitkä aikajana, selvä käsitys siitä, miten tiede, teknologia, tutkimus kehittyy. Ja on horisontaalinen akseli, joka on kuin tutka, joka seuraa uusia keksintöjä, uusia startuppeja, mahdollisuuksia. Täytyy osata nämä molemmat. Ja Yrjön vahvuus minun mielestäni on juuri tässä syvyyden ja sitten tämän uuden tarkastelussa. Kova tiede yhdistettynä leikkimieliseen kaiken uuden kokeiluun. Kiitän Yrjöä tästä matkasta digitaaliseen signaalin käsittelyyn ja toivotan hyvää matkaa jatkossa. Kiitos.
Kiitos Martti. Seuraavana Matti Kuusimäki. Professori Matti Kuusimäki oli Suomen ensimmäinen valtakunnan syyttäjä vuosina 1997-2010. Ja tätä ennen hän työskenteli ensin Vaasan ja sitten Helsingin hovioikeudessa. Matti Kuusimäki on muuten Vaasan Lyseosta, samoin kuin Yrjö, Jorma Ollila ja Matti Alahuhta. Kouluaikoina Matti ja Yrjö rakentelivat elektroniikkaa ja kuulemme nyt varmasti lisää hauskoja muistoja.
Hyvä ystäväni Yrjö, arvoisat kuulijat. Näiden pikkumuisteloideni otsikko on näpsäkästi seuraava. Kaikki alkoi syyskuussa 1948 Vuokkolasta. Minulle on suotu ilo pitää tämän seminaarin viimeinen puheenvuoro. Se sopii oikein hyvin. Jo siitä syystä, että olen kuulijoista varmuudella ainoa, joka on voinut seurata Yrjön oppisarkaa sen ensipäivästä lähtien. Niinpä olisikin ollut hävytön temppu, ellei Yrjö olisi tohtinut ottaa riskiä ja sallia minunkin täällä esiintyä. Sitä paitsi enhän minä, pohjalainen professorismies, näinkään fiinissä seurassa päätäni alha paina. Yrjön elinikäiset opinnot alkoivat virallisesti silloin, kun hän asteli ensi kertaa sisään Vaasan kaupungin Hietalahden lastentarhan 5-vuotiaiden Vuokkola-osastoon. Henkilökemiaista jo lienee johtunut se, että ystävyytemme siellä Yrjön kanssa alkoi heti. Tämä ystävyys siirtyi tarhassa 6-vuotiaiden sinikelloihin, jatkui luokkatoveruuteen sekä kansakoulussa että Vaasan maineikkaassa, kuten täällä on kuultu, Lyseossa, ulottuen edelleen opiskeluaikojemme kämppäkaveruuteen. Ystävyys on kantanut yhtä rikkumattomana maantieteestä ja elämän käänteistä riippumatta näihin päiviin asti. Varhaiskasvatuksen merkitys lapsen menestykselle elämässä on tutkijoillekin valjennut vasta viime aikoina. Mutta me olemme Yrjön kanssa aina osanneet ilman kasvatustieteilijöitäkin arvostaa lastentarhamme Maijutädin esikoulua. Syvästä arvonannosta on todisteena se, että pari vuotta sitten vanhoja taas kerran muistellessamme päätimme ottaa selvää, että vieläkö tuo iki-ihana Maijutäti, tuolloin aivan nuori lastentarhanopettaja Maiju Vuola, vaikuttaisi keskuudessamme. Ja kuinka ollakaan, turkulaisesta palvelutalosta löysimme yli 90-vuotiaan pirteän leskirouvan, josta emme olleet 70 vuoteen mitään kuulleet. Rouva Vuola tarjosi hieman jo varttuneille tarhapojilleen lounaan ja vietimme hänen kanssaan unohtumattoman iltapäivän. Kyyneliltäkään ei vältytty, kun keskusteluissa ilmeni, että tuo aikaansa seuraava uskomattoman muistin omannut rouva oli vuosikymmenten saatossa tarkkaillut kasvattiensa ja siinä joukossa meidänkin joskus julkisuuteen pulpahtaneita vaiheita. Olisi runsaasti kerrottavaa yhteisten lapsuus- ja nuoruusvuosien ajalta. Kuvauksia uskollisista pyhäkoululaisista, poikakerhojen lennokinrakentajista, vaativien partiotaitokilpailujen taistelijoista, esiintymisten suhteen uhkarohkeista nokkahuilutaiteilijoista ja ylipäätänsä puuhakkaista nuorukaisista. Nyt on kuitenkin pitäydyttävä vain eräisiin hajahavaintoihin siitä, millaisia signaaleja Yrjön ensiaskeleet 1950-luvun heikkovirtatekniikan saralla jo antoivat vuosikymmenten päässä siineleestä signaalin käsittelyn professuurista. Havainnot on helppo fokusoida yhteen sanaan. ja se on se transistori, josta täällä nyt on puhuttu jo uupumukseen saakka. Tuo puolijohdetekniikan mullistanut kolminapainen tulokas. Yrjön johdolla oltiin toki jo paljon aikaisemmin värkätty kidekoneet, ensin sellaiset, joissa kuuluvuuden aikaansaamiseksi piti metallipuikon kärjellä rapsutella kiteen pintaa, ja myöhemmin kätevämmät kiinteällä kiteellä varustetut. Mutta sitten vuonna 1957 Yrjö kertoi uutisia keksinnöstä, josta oli lukenut juttua tekniikan maailmassa. Bellin laboratoriossa Amerikoissa tehdyn keksinnön avulla pystyisi kuulemma rakentamaan taskulampun pariston virralla toimivan ja silti kovaäänisellä varustetun radion. Ja mikä tärkeintä tietää, näitä ihmeitä olisi kuulemma jo Helsingistäkin saatavissa, tosin kovalla hinnalla. Ennakkoluulottomasti päätettiin tekniikan maailman kytkentäkaavion pohjalta rakentaa molemmille 3 transistoriset radiot. Oma lukunsa on se, miten vanhemmat saatiin taivuteltua kustantamaan tarvittavat osat. Transistoreille lisäksi vastukset, kondensaattorit, kiteet, Pertinax-levyt, juotoskorvat, ferriittisauvat, antennijohdot ynnä muut. Aika hyvin muuten 60 vuoden takaa muistettu näin juristin muistilla. Insinöörin pojalle tehtävä oli helppo, minun historialehtori isälleni hankkeen perusteleminen oli vähän työläämpää. Äitiäkin siinä tarvittiin, kun pohdimme sitä, että mistä saadaan sopivat kuoret lattialla levällään olevien osien kokoamiseksi. Opettajaäitini keksi tuoda koululta vaneriset liitulaatikot. Siinäpä oiva ratkaisu aikana, jolloin muovituotteista ei vielä ollut tietoa. Radiot toimivat hyvin. Näiden teknisten hankkeiden toteuttajina rinnastuimme keskenämme mielestäni tunnettuihin kirjallisuushahmoihin Sherlock Holmesiin ja tohtori Watsoniin. Eikä tarvinne arvuutella, kumpi meistä oli kumpi. Vaasan Holmeset Watson elektroniikkapaja ei toki välttynyt vastoinkäymisiltäkään. Partiolippukuntamme riskisijoitus, mahtavaksi innovaatioksi ajateltu 6-transistorinen leiri- ja retkiradio ei syystä tai toisesta suostunut koskaan kunnolla toimimaan. Harmillista tilannetta lippukunnanjohtajalle selviteltäessä minä olin mieluusti vain tuo Watson. Kaikki kunnon tuotteet jalostuvat tuotekehittelyn myötä. Kun tapanamme oli tehdä pyöräretkiä Vaasan ympäristöön, ryhdyttiin pohtimaan vakavasti matkaradioversion kehittämistä. Tuumasta toimeen. Peltiset telineet ohjaustankoihin, toisiinsa yhdistetyistä polkupyörän pinnoista antennit, kuulokkeet korviin ja niin syntyivät valtakunnan ensimmäiset polkupyöräradiot. Mutta pari vuotta myöhemmin oltiin vartuttu niin, etteivät transistorit enää riittäneet vapaa-ajan koko elämän sisällöksi. Bill Haleyn rokkarit olivat vallanneet Suomenkin. Tarvettiin levysoitin juuri markkinoille tulleiden EP- ja LP-levyjen soittamiseen. Kodeissamme ei asialle lämmetty ollenkaan, koska vallitsi epäily, ettei soittimilla muuta sitten soitettaisi kuin rockia. Silloin Sherlock esitti, että okei, valmistetaan levysoitin sitten itse. Et voi olla tosissasi, epäili Watson. Mutta hankittiin sopiva puulaatikko, isä Olavin avulla Strömbergiltä valuraitainen sähkölieden levy, johon oli porattu keskelle reikä akselia varten, tarpeet muuntajan käämimistä varten, polkupyörän dynamomoottoriksi, erinäisiä hihnoja voimansiirtoa varten ja vähän muutakin tilpehööriä till. Vain sähköinen äänivarsi neuloineen oli tarpeen ostaa. Sherlock teki vetohihnalaskelmat, jopa 2 eri nopeutta varten. Stroboskooppikiekolla hienosäädettiin oikeat nopeudet 45 ja 33 ja 3/3 kierrosnopeudelle. Vahvistin rakennettiin vielä silloin radioputkitekniikalla. Sähkötarkastuslaitoksen luvat taisivat kyllä jäädä hakematta, mutta juristiopinnot minä aloitinkin vasta vuosia myöhemmin. Soitinta käytettiin erityisesti tuohon aikaan suosituissa kotihipoissa. Siinä yhteydessä Watsonillekin muodostui itsenäinen tehtävä. Jos näet vaasalaisneitojen maanittelu meidän hippoihin olisi jäänyt Sherlockin varaan, oltaisiin saatu tanssia kolliporukassa, vaikka miten hivelevät sävelet olisi uljas soittimemme ilmoille loihtinut. Sitten Yrjö siirtyi tupsulakkien kaartiin, kuinkas muutenkaan. Mitä hän sen jälkeen on saanut elämässään aikaan, olisi toisen tarinan paikka. Ja sitä paitsi, sitä tarinaahan on tässäkin seminaarissa setvitty pitkin päivää. Kansleri Tauno Nurmelan eräässä mainiossa teoksessa todetaan, että vilpittömimmän arvostuksen ihminen voi elämäntyölleen saada vasta sitten, kun hänen viimeinenkin luokkatoverinsa on ehtinyt nurmen alle. Minä nyt katson vielä näin nurmen päältäkin voivani toisena lyseolaisena antaa täyden arvon Yrjön työuralle. Mutta tämä ehdottomasti vain sillä edellytyksellä, että hän aina myöntää hänen olevan mahdotonta saada elinikäisessä opinsaunassa kuitenkaan minua kiinni. Yrjö kun tuli vasta 5-vuotiaana sinne Vuokkolaan, jolloin minä olin opiskellut jo kokonaisen vuoden elämäntaitoja lastentarhan 4-vuotiaiden lemmikit-osastossa. Kiitokset tilaisuudesta olla täällä tänään mukana. Menestystä Yrjön elämän jatkopuuhille toivotan, kunhan vain muistaa, että metsätöissä voi digiloikka olla noin vanhalle miehelle kohtalokas.
Kiitos Matti, siinäpä muisteloita. Tämä oli viimeinen puhujamme. Meillä on ollut mahtava iltapäivä. Haluaako Yrjö vielä summeerata? Omasta puolestani kiitän sekä yleisöä että kaikkia puhujia ja annan puheenvuoron Yrjölle.
Niin, arvoisa yleisö, tosiaan tässä on ollut varsin jännä päivä meillä, ainakin minulla takana, ja monenlaisia muisteloita on kuultu. Mitään erityistä summeerausta en halua tehdä. Mulla itselläni on paljon pohdiskelua tämän jälkeen ja positiivisia ajatuksia, mitä kaikkia tässä on puhuttu. Siitä sinällään aivan upea ohjelma ja aivan loistavat esitykset. On ollut todella nautinto niitä kuulla. Se, minkä tässä historiakatsauksen ohella on myöskin oppinut, kuinka oikeastaan modernia ja hienoa tämä tekniikka on, jolla tämmöinen tilaisuus tehdään, mutta myöskin sen, kuinka valtavasti työtä tämän järjestely vaatii. Ja tässä mä haluaisin tosiaan kiittää meidän erittäin tarmokkaita tekijöitä ja junailijoita, jotka vähän melkein niin kuin sanotaan puoliväkisin halusivat tämän tilaisuuden järjestää. Ella Bingham, Elina Karvunen, joka on tällä hetkellä sairaana, ja paikalla, ja sitten on Kristina Saiser, joka on tuolla takana, on jo ollut erittäin aktiivisesti tekemissä myöskin, ja sitten Sam Cross, joka on myöskin, jonka olette varmaan myöskin nähneet täällä. Tämä tiimi on tätä tehnyt, ja tämä on ollut kyllä aivan uskomattoman hieno kokemus myöskin sen tekeminen. Ja sitten Otto Olavinen kanssa, joka on itse asiassa tuottanut tämän materiaalin noista meidän vanhoista kuvista, joka on pyörinyt tuolla näytöllä aina silloin tällöin. Siinä on ollut, sekin on mennyt niin kuin, miten sanotaan, niin kuin todella kiireisellä projektilla lävitse, ja tulokset on ollut aivan upean hienoja. Ja tietenkin koko tämä meidän videoasetelmahan, tämähän on ollut mahtava, hyvin toiminut kokonaisuus, ja kyllä näkee, että meillä Suomessa osataan tätä tehdä tosi hienosti kanssa. Kiitos kaikille tosiaan, ja ei mulla sen suurempaa loppuyhteenvetoa. Tämä on ollut aivan loistava päivä. Kiitos. Joo.